Airlines, congratulations, you did see the title change. I usually have a little alarm set to do it right about 6:50 every day is when I'll go and change it right before we go live. I had some automation in place for it. That broke real fast and I was too lazy to try to figure out what's going on there. What's up, EJW? Good to see you. Thank you so much for the tier 1 sub. 3 months, that's love right there on a 2-month streak. So tonight's gonna be chill. Tonight's gonna be a short stream for sure. Because it has to be. I have to actually hop off to do something at 9 at the latest, but I'm actually gonna try to get you out of here by 8:30 today because something I gotta take care of. But we're gonna be learning about, we're gonna start diving into problem solving and algorithms tonight. So we've already been doing this, but we're gonna learn some practical concepts around problem solving and how to approach these different things. We'll learn a few concepts and we'll try to apply those concepts to some problems this evening. So let me get some stuff pulled up for you and we'll get it going. Crystallized Code, good to see you. What's up, Ain't No Profit? Vernon JC, good evening. Having a glass of peach wine that you made a couple years ago. That's dope. That sounds amazing. That sounds actually phenomenal. Some peach, that sounds, maybe we'll, in the future, when we get a little more, bandwidth, maybe we'll do like some wind down Fridays or something where we'll do a real chill Friday session. Instead of getting on here and learning a whole lot, maybe we'll just real chill, just grab some wine and sit back and relax and cross our legs and go through something. I don't know what we'll do, but maybe we can do that a little bit later. What's up, Ricadius? What's up, Denzo? Good to see you. All right, let me get this. This is what day is this? Day 12. Let me get you all these links to these slides so that we can get going, talk about this stuff so we can get through it pretty quickly. Yeah, wind down 100%, or wind up, wind up for the weekend, wind down, from the week. It's all good. Do what you got to do. Great material. Slides, edit, drive, intro to algorithms. I'll give you the cooler looking one. There's an old one in here. Post it. That's there. Is it live? Let me get you over to the Academy screen. And let's get you these. Swarming here. Side note, anyone who is looking for one of the new 5000 series processors, one of the new AMD processors, there was a huge drop across the country yesterday. Probably sold out online at most places, but there's probably stores that might be near you. Might be some Best Buys, Micro Centers. There might be some stores nearby who have some. You also may be able to get one secondhand for much cheaper because there was a huge drop of them like nationwide yesterday. The Micro Center today had like midday, they still had like 5950Xs or something like that. Pretty crazy, to be 100% honest. That's never the case. But just go take a look. Go take a look. I think there was also a big like AMD card drop as well. I can send an upgrade, but don't need it yet. Yeah, I agree. Hold on to your money a little longer while yeah, hold on to it a little bit longer. This generation will be around for a while. I will confirm though, if you are a generation already like old, it's a pretty, if it's for gaming, it's a pretty massive increase in performance. So wait till they're available. Don't pay the markups. But I was surprised to see such a large drop of like everything. They have been getting like 15950 a day, like every day. Like maybe they would get one like a shipment like twice a week. They would get a bunch of Ryzen 5s, a couple Ryzen 7s, and like one Ryzen 9. And yeah, your 1700X still buzzing along. Keep it. You don't have to upgrade your motherboard or anything like that. Keep it as long as it's good for. I will say I had a 1700X first, and then I got a 2700X, and I had that 2700X that was a workhorse. I did a lot of stuff with that 2700X, and it was perfect. It's still in use. I think I just built a computer for my nieces and nephew for Christmas, and they got a 2700X, and they got I think I got them a 2060 or something, 2060 Super. So like all they play is Roblox anyway. So you know they're living good. They didn't need any. They were cool with their iPad, to be honest. So let me get this link. Anyone with it? Let's remove this one. Copy it. Get it to you. All right, now people can get slides. Slides command is all set up. And here we go. Let's get going so that we are all done. For Roblox on 4K, they do have so I did give them a, because I went 4K, I did give them a 1440p monitor, a G-Sync monitor at that. So they are playing Roblox in up to 144 hertz, most likely 144 hertz G-Sync. You know, it's definitely overkill, certainly overkill. But because I had all the other parts sitting around, so the only thing I had to get for them, you know, for a Christmas gift for the whole family, all I had to do was get them I had to get them a graphics card, and I had to get them a hard drive, and that was it. So, you know, I went to Micro Center. One gift for all 3 kids. I figured I'd, you know, drop a little bit on the 2060. I was gonna get them a 1660 Ti and figured I'd just go one bigger so it lasts a little bit longer. But for what they need to do, it should last a very long time. Real interesting prices at 3080 Ti. Yeah, I mean, I agree. I agree. I kind of wish I would have waited. I also wish I had a 3080 at one time. I wish I would have kept the 3080. The 3090, I do not utilize in the way that I could utilize it at all. I don't think most people will. And all it does is it's made it so that it covers up one of my PCI slots that I could be using, because it's a 3-slot card. That's super trash. And it puts out massive heat. So right now it's fine, but when we get back to summertime, I have to imagine it's gonna be a real problem. I should have kept the 3080. It was perfect, perfectly sized, a little bit, even though it was three slots as well, it was a smaller card and put out much less heat, but you know, it is what it is. All right, so introduction to algorithms, and this is really introduction to problem solving. It's very interesting when we talk about algorithms as is, and where people's mind usually goes. The concept of an algorithm is a pretty simple one, and people talk about it all, you know, people talk about it as this big, giant, scary thing, and an algorithm itself is not scary at all. It's just kind of a set of rules. Really, it's a process of getting somewhere. But we are going to learn some steps you can take to be able to properly approach any algorithm you come up against, so that you're a little less afraid. So a lot of times if you're trying to be a software engineer, to get a role, you'll be presented with some type of challenge, some type of coding challenge. All the FANG companies out there, you know, Facebook and Google and all those places, Netflix, they all have made us fear what we might run up against. They give out pretty ridiculous problems, or historically they've given out pretty ridiculous problems that may or may not test the true ability of someone, and you know, they've been pretty scary in the past. Other companies still do this. We need to know how to approach these things, but we also need to understand how to approach any problem that we do run into in the workplace. And so that is what the goal is tonight. Let me pull this up and silence this so I don't keep getting alerts in my ear. I don't like that at all. All right. Down, cool. So let's do it. Welcome to deCoded, introduction to algorithms, problem solved. So what I want you to do tonight, as is the case every other night, tonight I want you to focus on the concepts. Conceptually you need to understand these things conceptually. You need to understand what we're doing when we're problem solving conceptually. You don't need to focus on the little itty bitty pieces of the problems. Just simply focus on the concepts. What's up, Lambert? Good to see you. All right, so what in the world are algorithms? When everyone talks, people usually talk about algorithms with data structures. I'll give you some insight into that as well. But algorithms, what are they? It's simply a process or a set of rules to be followed in calculations or other problem-solving operations, especially by a computer, okay? Oh, no, hold on. We got a little, uh-oh. We're in a little network hiccup right now. Oh, hold on. Let me see if I can see what's going on. One second. Chrome. Let's go ahead and kill Chrome. I think we're back. All right, we're back. All right, maybe I didn't go away for some of you, but I definitely dropped a bunch of packets just now. I think we're okay and good to go now. Cool. We look to be stabilized once again. All right, okay. You know, we gave Comcast their credit yesterday, and then they immediately respond with this, but it's all good. I think it's back. So we'll keep going. But yes, all it is a set of rules to be followed in the calculations or the problem-solving operations, especially by a computer. So, no, that was Burton JC. That was me. That was me because I was talking and it looked like we were completely dead. So you know, gotta throw that in there. So you might hear companies or these companies will come out and say, yeah, we have an algorithm to help people find houses better. You know, our algorithm, we got the algorithm. People talk about the YouTube algorithm. This is not some super crazy, it could be some kind of crazy fancy special thing, but really it is just a set of rules to be followed to get to an end goal, generally automatically. Sin City, thank you so much for the tier 1 sub. 7 months, that's love right there, appreciate it. Fried Clam, welcome to the channel. Thank you so much for the follow. So pretty simple, not anything crazy. No, you see all these lines over here, you might think it's some special math thing. No, just set of rules to be followed. All right, so now that you know what an algorithm is, oftentimes an algorithm is going to be the thing that you're creating to go from the start of something you need to solve to the end goal. It's going to be the steps that need to happen in your code to be able to take some input and get the output that is required of you. And to do this, we need to understand how to problem solve. That is all you're going to be doing in coding. You're getting paid to solve problems, usually business problems. You're getting paid to be presented with a thing that needs to happen, and you got to figure out how to make that thing happen in code to solve what the business needs. And so let's learn how we do that. What's up, Unique ID? Good to see you. The very first thing that you got to do to be able to understand, to be able to solve any problem, is to first comprehend that problem. That is step 1. Write it down. The number 1 thing you need to do before you can solve anything is to comprehend the problem. You have to understand what you're trying to solve. Consume the problem until you feel comfortable. I cannot say that enough times. Consume the problem until comfortable. To solve a problem, you must first understand the problem, even if it means reading the problem 10 times. And that is okay. A lot of times people will read a problem, and because it's confusing, they will either back off of it or they'll begin to think about solutioning of it immediately. You need to first understand all the pieces to that problem, okay? Read it over and over again until you do. Ask questions until you do. Make sure you understand what's being asked of you. And this is not only, yes, this is in terms of algorithms, that's exactly what I want you to know. But going a little bit further, for when you are in a role, when you're actually working somewhere, don't even make sure that you understand what's being asked of you in the problem. Make sure you also understand what's being asked of you in the context of your company and your organization. A lot of times you will be provided work by someone who doesn't, who may or may not know the full scope of what needs to happen, and they're leaving a portion of it up to you to use your professional engineering prowess to kind of fill in the gaps here. And so when you're working with someone, when you're working for a company, make sure you understand how this problem fits into the greater good, because someone might have told you to implement something that you don't actually need to implement, or that needs to go a different direction or something. There's a lot of things there, but make sure you understand the problem and how it fits in when you're working somewhere. For just an algorithmic problem, for when you're trying to pass something for a coding challenge or something, just make sure you understand what's being asked of you in the problem. Read it up to 10 times. All good. I really find it helpful to try to solve the problem manually first before starting to think about solving it with pseudocode or coding. Yes, Yes, we're about to talk about that for sure. Hate when people read the problem and then start a temper tantrum. That's the worst. I agree. You don't need to do that until later. What's up, EQ Explorer? Thank you so much for the Twitch Prime sub, 4 months. That's love. 4 months of no ads. I love it. Don't put effort going down the road that you'll just end up abandoning later. Yeah. So it's okay to eventually throw a temper tantrum. Maybe when you do get into the problem solving portion of it, you run into some challenges. Sometimes a temper tantrum is okay. We'll talk about that as well. But make sure you understand, consume the problem, comprehend the problem first. Can't really go much farther than that until you do that. Then you want to break it down. All right. What's the famous phrase? The best way to eat an elephant is one bite at a time, or something like that. Could be making that up. It seems like something I've heard before. But inch by inch, life's a cinch. Sometimes you got to stop looking at the entire forest and start looking at the individual trees. Break the problem down into manageable pieces. So first, understand what it is that you have to do. Then once you understand it, take a look at it and break it down into consumable pieces, okay? The smaller you can break it down, smaller chunks you can break it down into, the easier it is to approach it. Everyone, if someone tells you, again, to like this guy's chopping down all these trees, if you look at all of it and you're like, I got to chop down all these trees today, kind of sucks, but look at him. He's taking his time, making some firewood, and he's going to get into a place where he can transport this stuff, no problem. But yeah, you break it down into little chunks that you can solve individually. It makes it a lot easier for you to do overall. Also, it allows you to focus on specific aspects that can kind of keep you moving forward in the problem rather than getting stuck trying to think about it holistically. So don't try to boil the ocean. Yes, that would be problematic. Or maybe it'd be pretty easy if you, global warming, maybe something about that, and take a while, but you could probably do it. All right, so inch by inch, life's a cinch. Just break it down. Understand it first, break it down second. Now, I actually really like what Second Billing Cycle said about solving it manually, but although I like that, I'm gonna include that in this pseudocode piece, all right? Pseudocode, what in the world is pseudocode? Well, it's simply code that is in fact fugazi, okay? In computer science, pseudocode is an informal, high-level description of operating principles of a computer program or algorithm. This is textbook. We'll talk about what pseudocode is in a little bit. It uses structural conventions of a normal programming language, but is intended for human reading rather than machine reading. That last line is the most important piece. It's intended for human reading rather than machine reading, but it's not real code. We'll talk about that. Mr. Don Brown, welcome to the channel. Thank you so much for the raid, Andy Shin. Everyone, come on in, relax, get comfortable. We're just talking tonight about how to approach problem solving, whether it be code, whether it be whatever you're doing. It's good to have you. Let me give you a shout out. I hope you had an amazing stream. Let's see. Make sure I spell that right. There we go. Thank you so much for coming through. Welcome. Good to see you. Yes, Fugazi, the waiting room. Exactly. It's not real. Okay. And so break this down a little bit. It's high level description of the operating principle of a piece of code. So Second Billing Cycle stated that we should solve this thing manually. Okay. And so solving it manually might be writing out, drawing some pictures, drawing some arrows, and, figuring out logically how you might solve this thing. Maybe you want to use little props on the table, whatever you want to do. You may want to do that. And maybe you ultimately want to actually solve it, with your hands if possible, and try to get an actual answer so you kind of understand where you're going with this problem. Fugazi, I don't know, well, it was right here. I didn't really mean Fugazi, Pseudocode, which is Fugazi code. It allows you to be able to express that same manual logic, or do your best to explain that manual logic in a code-like structure that follows conventions of coding, but without having to actually write code. So it's language agnostic. It's not a real thing. This is a very loose definition of things, and so it can be used to help you do a lot of stuff. So let's look at some pseudocode really quick, and then let's actually write our own pseudocode so that we can do some stuff. Follow Mr. Don Brown for that sweet Python coding. Please, absolutely, 100%. Let's see. What are we looking for? I already forgot. A pseudo code. So it's really funny because you'll see this done in so many different ways. There are some standards for pseudocode. You don't take any of your time to learn any standards for pseudocode, but it often looks, it's structured like code often, but it's not actually code. Let's see if we can open this in a new. And I'm gonna write some of it out for you, but take a look at this. It says program start. All right, that's where the program gets initiated. That's where we get into things and initialize a variable A. So instead of actually writing the code to initialize a variable and assign it a value, we're writing, hey, we'll make this variable here. We'll create this thing here. We'll start a loop. We just want to start a loop up, and that loop will do certain things. It's going to call this function here, and you try to structure it in a way that's going to show you the logical operations you might need to be able to solve this problem. All right, so it's a good way. It's a good practice to kind of start. I don't write a lot of pseudocode nowadays, to be 100% honest. I might draw some images first, and I am pretty visual, so I might draw some pictures or something to see if it could help me kind of understand the logic of what I'm trying to do. I don't do a lot of pseudocode personally, but maybe I should start. But it's pretty cool. There are no rules to this. You write some stuff out. You'll see. Well, I'll write some out. Maybe some of you should also write some out while I'm writing some out, and we can see how they differ. Send them over, see how your pseudocode looks as opposed to the one that I create. But it's it's wide open to how you want to do some of that. What's up, Jobus? Good to have you. Joey Cash, I think I missed you there. What's up, Predon TV? Good to see you as well. Where's my mouse at? See if I missed anybody else. Sin City, I'm not sure if I got you for the resub, but if I didn't, thank you so much. I think I got everyone else on there. Cool. All right. And that might be the last slide for what we're gonna do. And then you code, and then you actually do the coding. So that's a basic problem solving life cycle here. Consume it so that you can comprehend it. Okay. Then you break it down in little pieces. After you break it down in little pieces, you can write some pseudocode. You can manually kind of solve this problem and begin writing the structure without having to write actual code. Do your best here. I am under the belief that you do not have to complete the problem via pseudocode. I prefer to write the logical chunks in pseudocode, and I usually never tie it all the way off, even when I do write pseudocode, because I think the pseudocode should be there to guide you rather than to solve the entire problem. That's how I feel about it. Some people feel a lot differently about it, but yeah. So you write your fake code, and then you write your real code. After you have the logic down, after you kind of understand how you want to solve this problem, then you do the actual coding. And I think we all know what that means. And the last slide here for this is using your tools, okay? So whip these tools out so that you can, to see what you can do. So remember, when you are trying to solve a problem, this was said to me a long time ago. People use this all the time. Some people don't subscribe to this. I really, really, really subscribe to this especially for things that are going on at work, things that you would get paid for. People are paying you to make it work, okay? They're paying you to make it work. So one of the first things that you should focus on. Now, if you can do all these things at once, that's great. You should keep all these in the back of your head, but this is a priority order. Make it work first, okay? So do what you need to do to make the thing work. All right, solve the problem. All right, after you solve the problem, because remember, everyone's gonna give you all these ideas and all these notions about why code needs to be perfect and why it needs to be super clean. Yeah, yes, these things help. I don't care what anybody says. These are not essentials. Clean code is not an essential to be able to make money and to solve real problems for a customer or for a company. It's not essential. It's something that will come though. It's something that will come and something that you should not ignore. But you want to make it work first, then make it correct. Okay. That is a secondary option to making it work. Make it work. If you can make it right at the same time, please make it right. And the last is make it fast, okay? This is talking about performance. not necessarily talking about, get it done quickly. Yeah, you do want to do that as well. That kind of falls into the make it work portion, but make it work, make it right, make it fast. All three important things. It's not saying do one and then the others. It's just saying this is a priority order. If you can only make it work, make it like, if you can only do one, make it work. If you can do two, make it work and make it right. And if you can do all three, make it work, make it right, and make it fast. Okay. That is, I will, from all of my knowledge now, from all the things that I've seen, I will always push this concept to people because I think it's something that stops people from being able to solve problems. I think not following this has caused lots of people not to get jobs at all because they sometimes they never even end up turning in the coding challenge because they are focusing so much on optimizing the way that they are sorting something and doing this and that they never actually get to an end product or to an end goal. And then they get, or if they do get there, they're unsure of how they got there because they went everywhere else looking at everyone else's idea of clean code, and they're not really sure of what happened, like why, yeah, it's super fast, but they don't really understand why it's fast because they copied and pasted it. So, just make it work, make it right, make it fast. Balancing done right and done on time is tough. It is. Done right and done on time is tough. I can't tell you how many times on your job, I don't care who you are, I don't care where you go, where you will be doing something is going to be due, and you're going to be struggling. Other people are going to help you out. You're still going to be struggling because it's a hard problem to solve, and you're going to put in something hacky, and you'll say, we will come back to this later. You ain't coming back to that. You ain't coming back to it. But it'll hold up for years. It'll hold up until it needs to be touched again sometimes. But yeah, just make it work first, then make it right, then make it fast. It's just priority order here. So very simple, problem solving. It really isn't, conceptually, it's not that difficult. Okay. The problem is inside of each of these items, there's going to be different tools that you can utilize to be able to get better at them if you want. So comprehension is kind of comprehension. It'll be, the more and more problems you see, the more and more problems you'll be able to understand. That's one of the very interesting things about these coding challenges. It's kind of like escape rooms. If you've ever been to an escape room, the very first escape room that you go to is very difficult. The first time you approach it, you're like, bro, I have no idea what to do here. How are we even supposed to start here? And then as you go through it, you start to learn, you start to feel what to expect. You start to understand what to expect. And then the next time you touch an escape room, you're a pro. It's super easy to solve the problem. It's great. If you've never been to an escape room, there's a game on phones. I don't know if it's on Apple, but I assume it is. It's called The Room. I think there are 4 of them now. It is kind of a phone escape room thing. It does cost like $1.99. I highly encourage you to download it if you've never been to an escape room before, and kind of go through that, see how it teaches you, see how easy it is once you get to the second game or to the second room or whatever, how easy it is for you to find answers, because you understand the rules, you understand what's expected of you and what's being asked of you. These coding algorithms, these coding challenges, the more and more times you see them, they are asking you these questions in a way that is going to cause your mind to start to think like a developer. You're gonna start thinking like a computer, and you're gonna start thinking about what tools you have in your pocket that you can use to implement some of these things. It is, you'll become more comfortable over time, but you still gotta read until consumption. So until you can comprehend it. In the beginning, it might take 10 times. As you get farther along, as you've seen more, as you understand what's expected more, you can read it less and less times. Breaking it down, this is an interesting one. It will take you time. The more problems you see, again, it'll take you time to fully understand how you can how many parts you can break a problem down into, how many is too much. It'll take some time to figure out the finesse of how much you should break it down, because it is possible to break these things down into too many small parts, to be honest, but it's okay. In the beginning, I wouldn't worry about that at all. Do your best to break it down as much as you can, but you'll start to learn what kind of things go together and what you should keep together and pull apart. It's pretty interesting. And then again, pseudocode, you'll make up your own pseudocode. You will make up your whole own way of doing this, and then you'll have your own coding style as well. Cool. Let's do some practice. One of the ones, I think we did it last time we ran this course. One of the ones that I really like to do to practice this is on exorcism. There is, I think I might have completed it here, maybe not. And again, every time it's different. It's Lun. It's the Lun algorithm. I think I gave you this. I think I gave you all this as one of the options that you might want to do in one of the assignments. We are going to do this one first because I think this has a number of different aspects to break down, and I really like it because it utilizes pretty much all the things that we've learned so far here. I will do this. Yeah, let's do this and go. And yeah, we'll get going. So in exorcism, you can grab the Lun practice problem. We'll go through it. We'll end up with some random code. We'll see it. We'll see how we get there. We're gonna break it down, make sure we understand, figure it out, and we're gonna follow those steps so that we can see how it's done. We'll write some pseudocode as well. Sir Stash, welcome to the channel. Good to have you. Thank you for the follow. So let's do it. I'm gonna take it. Let me get logged into my system here and get ready. Archer, good to see you. Thank you so much for the follow. Good to have you here. Welcome to the family. All right, so I'm in this. Let me see. It looks like I downloaded it before. I'm going to CD into exorcism. Go. Is it in here? It's not in here. Good. So I probably haven't done it in a long time, but again, it's a really good problem to break it down to. I hope we can finish it. Developer speak is like a whole subculture that takes time getting used to. It is. It really is. And again, the best way you get used to it is to immerse yourself in it, to read a lot of problems, to try a lot of problems. Even if you never, there's a lot of value in trying problems, even if you never get to the end of them, and practicing thinking about it and try, like, you know, really going through it as much as possible. That is why I really like some of these platforms where you can go to see other people's answers, because you can set a timer for yourself. You can say, hey, I'm gonna grab this coding challenge and I'm gonna spend 6 total hours over however many days you want to try it over, whatever, and say, I'm going to give myself 6 whole hours to try to finish this coding challenge total. And you can put in as much effort as you want. You can, you know, research everything you want, look up everything, and you will learn so much in that 6 hours of self-exploration. You will learn so much, even if you never solve the challenge. And, you know, then you can go look at the answer and you can find some solutions and look at them, see if you understand them, and it'll start to open up some more doors. And then you go to the next problem and you say, cool, I'll give myself 6 more hours, and then try that out. And you'll see the words, you will start to see the patterns and the way that people, the information that's portrayed to you. It's pretty interesting. All right, so we grabbed this Lun problem and we are gonna go into it. So I'm gonna CD into Lun and let's get going. What in the world is this Lun challenge? Let's see, let's look at the README. Okay, so Lun, given a number, determine whether or not it is valid per the Lun formula. This is great. The Lun formula, a simple checksum. So there's a Wikipedia article here. Again, remember we said read, comprehend, comprehend, comprehend. Let's comprehend. So they give us this URL right here. Let's go ahead and I'll just do Wikipedia. Actually, I could just go right here. And it's probably in here and we can read about it. Okay, the Lun algorithm or Lun formula, also known as the modulus 10 or mod 10 algorithm, named after its creator. So now we've learned that some guy named Lun, we don't know his first name, Peter Lun, has created this algorithm known as the modulus 10 or mod 10. So we know what modulus is, so it should help you out a little bit. Definitely should help you out a little bit into thinking about what to do. And then it says it's a simple checksum formula used to validate a variety of identification numbers, such as credit cards, IMEI numbers, those are the little numbers on your phone, national provider information identifier numbers in the United States, Canadian social security numbers. Great, a bunch of different stuff here that it's used to validate against. Okay, so cool. It's going to be a formula that's going to allow us to ensure that these things are valid. Exciting. So, you know, we're learning something here. All right. The task is to check if a given string is valid. So we are gonna, it's already telling you right now, we're gonna grab a string and we're gonna see if it's valid. Validating a number. Strings of length 1 or less are simply not valid. So that's a helpful thing that we might want to write down. Spaces are allowed in the input, but they should be stripped before checking. All other non-digit characters are disallowed. Okay, so any non-digit characters are disallowed. So that might be something we have to do something with, maybe. Example: this is a valid credit card number. So they're gonna give us some numbers that has some spaces in it. The first step, so now they're giving us the steps to do this thing. The first step is to double every digit, every second digit, starting from the right. Okay, so every second digit starting from the right, we'll be doubling. Okay, so it looks like they chose, second digit is 6, then 6, then the 4, the 0, the 8. All right, so they skipped every 2 starting from the right, not from the left. That's pretty interesting there. If doubling the number results in a number greater than 9, then subtract 9 from that product. Okay, so if you double the number, if we double something like 6, 6 times 2 is 12. It is bigger than 9. So then we must subtract 9 from that number, from that product, okay? The results of doing so will give us this. So they've done the doubling for us using this algorithm that they've given us. So this is the algorithm. Like what we're reading right now, this is the algorithm to solve it. It is not the code, it's not the coded version of the algorithm, but this is the algorithm to solve this problem. The Lun algorithm is this. All right, every second number from the right, double it. If it is more than 9, subtract 9 from the products. Then you add up all the digits, sum all the digits, so you add all the digits together. If the sum is evenly divisible by 10, this tells us why it's the modulus, the mod 10 algorithm. If it's evenly divisible by 10, it is now valid. That's great. Okay, so now we've learned all the steps that you need to take to get to this end product. Tormik, welcome to the channel. Monique, live, welcome to the channel as well. Good to have you. Hopefully you're ready to learn a little bit of algorithms and problem solving tonight. So, invalid credit card number. So they give us another example here and we can look through it and kind of understand. So let's first, to ensure we understand what needs to happen, let's go ahead and let's write down, let's write down what we think we're supposed to do, okay? It tells us, but let's make sure we understand. This is not gonna be pseudocode. This is us just starting out and getting ready to build what we need to build. All right, so we'll call this, our Lun algo. And again, first part, comprehend. Making sure we comprehend. All right, so the goal. What is the goal of this? Is to create an algo that validates string input. All right, so that is what we're trying to do. That's what we're trying to solve. All right. What's up, Rose Gold? How you doing today? What lessons are being taught? We're just learning how to approach problem solving using code so that you can approach algorithms in the future. So that's the goal right here, okay? What do we have to do? Okay, so what do we do? So what do? We simply, it says the first thing that needs to be done is that we need to double. Oh, actually, first thing is this: strings of length 1 or less are not valid. So we need to create some type of validation check. So strings of less than 1 aren't valid. Spaces are allowed in the input, but they should be stripped before checking. All other non-digit characters are disallowed. Okay, so one of the first things we have here is we have to clean our input, clean input, which would consist of remove spaces, check length is greater than 1, and we also need to disallow non-digit characters. Whoops. All right, so that's the part of our clean input. That's what they told us. This is what I understand of the problem. So spaces are allowed, but they must be stripped. Things of less than of length one or less. Is it one or less, or is it less than one? Strings of length one or less. So that should help you. That should help you out. So if it says something is one or less, that means we should probably do an a less than or equal to operator rather than just a less than. Okay, great. He's a Corey. Thank you so much for the tier 1 sub. Welcome, welcome, welcome. Good to see you today, and thank you so much for the love and for the support. All right, so that's the first piece. Then we need to go through, and we need to, first step is to double every second digit starting from the right. All right, so I think I understand that. So to double each digit from right. Okay, that seems interesting. So we're gonna double each thing from the right. Oh, actually, not each digit. Double each every other digit. Sorry. From the right. Great. And then after we do that, we need to, if the number is greater than 9, we need to subtract it. We need to subtract 9 from it. Okay. So you should already start to be thinking about certain tools that we have available to us. So if doubled num is greater than 9, subtract 9. Okay, that's the next step. And these are my different pieces. That's why I'm writing the numbers here. These feel like different pieces to me, but I don't yet know if I might be able to combine some of these, but I just want to break it down to everything that I have to do. Luckily, they've given us this step by step. So in this problem in particular, it's helpful in the way that they've given it to us, but you know, let's see. And then we need to add up all the digits, and then we need to see if it's evenly divisible by 10. So add up all digits. 5, check. If sum is divisible by 10. All right, so we got what seems like around 5 steps here for what we have to do. And I think that's all the stuff here. Yeah, and we can see if that works. So now that we understand, I think we understand this. Anyone have any questions about the problem itself? Okay, to make sure we understand, does anyone have any questions about this? About what we're about to try to take on? And everyone who joined a little bit later than the beginning, this will probably be the only thing that we do tonight. This problem itself, I got to get out of here as fast as possible tonight. So this will probably be the only one that we do, that we kind of practice all this with. We'll see how fast we get through it. All right, doesn't look like there's any questions about that. So let's start to do our code. Okay, we have our README here if we ever need to refer back to it. But now we can go ahead and we can write our code and we can get going. So one of the first things that we want to do, we've seen exorcism before. We've seen the breakdown of exorcism. We know that exorcism practices test-driven development. So they're going to give us some tests that we can use to help guide our implementation as well. Let's also see what stub code they gave us, because they usually will give you some stub code. And it looks like the only stub code they've given us is simply this file that has the package here. So that's great. You know, no big deal. Phenomenal. So we got to write just about everything. And so now we need to go to our test to make sure that we understand what else we need to do. On the doubling digits part, the right is the last index, correct? Yes, Burning JC, it's the last index, correct. All right, so here we go. This test right here may be a little bit difficult to read, But this test right here, let's show you some things. One, the test immediately gives us the name of the function that we need to write. The function that's gonna run is this. Okay, that test valid. Let me change the color because that doesn't show up as good as I wanted it to show up. And let's erase that, but they're gonna be calling test valid, all right? And they're gonna pass that in and they're gonna run it against some test cases. All they're gonna do is run an assertion to say, hey, I'm, with this input, I'm expecting this output. There's another file that handles those. Whoa. Oh, sorry, I forgot. It feels like I'm in Vim right here when I'm not in Vim. So let's go back over here. Let's look at the actual cases and the output and the value. So single digit strings cannot be valid. So they're giving some descriptions for these test cases and it's saying, hey, if they pass in a 1, they should, our algorithm should determine that the number 1 is not valid according to the Lun algorithm. A single 0, same thing here. So we have a bunch of different test cases that we know we need to write code to solve. So a simple valid SIN that remains valid if reversed, 059, okay, that'll be true. This will be true. Very interesting, okay. So 59 is true. Why is 59 true? Because we're gonna go to the left, we're gonna double it. Actually, it's gonna be greater 1. Oh yeah, very interesting. So 59, why is it true? If you go 1 from the right, 5, you double it, it's 10. It's over 9, you gotta subtract 9, so it's 1. 9 plus 1 is 10. That is evenly divisible. Okay, okay. The function name is valid on line 7. Okay, let me go check that. Maybe it's valid that we need to check. A valid Canadian, so they give us a bunch of different options here and we can see some stuff. We see some ones with spaces in it. Do we see anything else weird? Invalid here, we have a non-digit in this one. So we know that we might have to handle that. Not might have to, we'll have to handle that. $, great, cool. Okay, let's do this. Let's we have some things that we can see against, we can check against. Let's go ahead and see what's going on here. Let's look back at the test because I may have gotten that wrong. Whoops. Oh yeah, you're right. It's valid, not test valid. It's valid. Right there. Good call. What's up, Kippers? How are you doing today? Welcome to the channel. Thank you so much for the follow. Cool. So yeah, so the function name is valid. So let's go ahead and now having this, let's go ahead and let's build what we can. So what I'm going to do is I'm first going to, I kind of want to transfer everything that we put in the drawing. I kind of want to transfer it in here so that we don't have to keep looking back at this. So let's go ahead and throw some comments in here and let's start to build out our code over here. So let's add in some stuff. First thing is going to be, we need a clean input. And let's see, I'll put in parentheses, length, 1 or less, invalid, strip spaces, and what's the last thing? Disallow non-digits. All right, so that's one section here. I'm gonna separate them all, double every digit from right. It's going to be another one here. And I'll make a little bit more space and we'll do we might be able to combine these, but if greater than 9, subtract 9. Okay, and add up all digits and check if sum is divisible by 10. Okay, excellent. We got it. We're ready to go. Oh, one thing we didn't do, one thing we didn't do is we did not do, let's open up OneNote. Let's write a little bit of pseudocode here now. Now that we have what we need to do, let's try writing some pseudocode. Okay, for even the parts that we just have in here, let's go ahead and give this, let's give our paper some lines or something. How do I do this? There we go. Let's give it some lines. All right, so we need to make sure that we clean the input so we can talk about that. So why use OneNote when you can use Notion? So I can't, that's fair. One, because I don't think I have Notion installed on this tablet. I do, I lied to you. So we do have Notion here. But also it felt like it was gonna be easier to write out. We can do it in here. Let's create a new one. I like it. Let's do Notion. Let's also turn this to dark mode because, you know, this is not for me. Appearance, dark mode. And yeah, let's do that. That's fine. We can do that. And so let's call this right here, algo, pseudocode, algo fugazi code. How about that? You know, there we go. And we can actually write a code block in here, and let's go ahead and let's do it in here. That makes sense. I agree with you. I agree. Dark mode's the only way. It's the only way. What's up, Pels? Welcome to the channel. Thank you so much for the follow. Okay, so what will we do this in? I think it has a Go option here. Even though we're not writing in Go, we are just going to be writing some text. So we want to break this down into those little pieces. So when we were writing these things, what did we learn is a reusable chunk of functionality that only runs when called. That's a function. And so we can kind of break this down into little functions to help us. Maybe that's the best way to solve it. Maybe it's not. But as we start to get it out in our pseudocode, we may be able to see where some of those oddities lie. So let's go ahead and let's do that. What's up, Lil Zambot? Good to see you. So let's do the first part. Let me put pseudocode here. so people who are just joining understand what we're doing here. So pseudocode for this. The very first thing was to clean the code. So we'll do, you know, create function to clean input. All right, and then you know, inside of that function, you know, we'll follow some of the same paradigm. So we'll put little tabs here. This is how I would do it. You can create your pseudocode however you'd like. And I say, all right, in this little piece of functionality here, we need to do something that says it needs a check for the length. Okay, it's invalid if it has a length of less than 1. Okay, so we can say something like if length of input is less than 1, in the same way that we would normally do something like this, we could say, you know, return false or something like that. You know, and this looks a little bit more codey than something else might look, but I mean, that's just kind of the nature of this piece right here. Yeah, Notion is it is sick. It's really, really good. It's a really good product. All right, so that might be something like that. Create a function to clean input, and the first thing that we do is if length of the input is less than 1, return false, and then we have some other options in there as well. We might say strip spaces. So, you know, I might put right here, replace spaces in string with non-spaces. And so if you do know the functions and things that might handle this for you, you can kind of write those in as fillers if you'd like. But you know, if you were going to loop through something, you could. So if I was going to write a loop there, I could write begin loop and then replace all strings with non-strings. I know that there is a strings replace function. I don't know what the keyword is for calling it. I don't know what the actual function name is, but I know there is a function that will allow us to replace some text. So we can see that here. And then we can say maybe check for maybe loop. I don't know. Begin loop. If character is not a number, you know, we can do something like return false. Okay, and this function, the last piece of this little function right here might say something like, you know, then return return input is valid. If it makes it to this point, maybe it's going to return the input is valid down here at the bottom. Joe Flu, what's up? Sir Squitty. All right, Sir Squitty. I'm gonna try it one more time. Nah, that's all I'm gonna try. We are learning how to solve. We're doing the Lun algorithm in Notion. I can't give you the link to it, but not Notion. In exorcism.io. If you head over to exorcism.io and sign up, there is a Lun algorithm. I'll send you the Wikipedia page that we have up here. If anyone wants it. It tells you what the Lun algorithm is. We're solving it in Exorcism, but right now we're writing a little bit of pseudocode. Oh, why did it not copy that? It did not copy that at all. That will download it for you, but this is the actual algorithm right here. And we're doing some pseudocode right now to kind of talk about how we're gonna actually write the code to solve this. So, all right, so that might be a function here. And so this is giving us a good structure. Maybe that's not exactly what we want to do, but it feels right, okay? Now that we have this little bit of pseudocode up here, what else do we need to knock out? We need to double every digit from the right. How in the world would we double every digit from the right? We could do this in a number of ways. We could loop through each of the things. How can we loop through it? We can loop through it because it is it's a string, and strings are just a list of characters. So we can operate in it like it's a collection because it is a collection of characters, and we can loop through it, and we can, let's write that for now. That may not be the best way, but we can loop, begin loop, and begin loop, and maybe we'll say begin loop beginning at end of input. Okay, so that we know that we're gonna start from the right instead of the left here. And then maybe we might want to say double every second digit. All right, and so we'll have that there. And cool, that might be all we need to do, but it still feels like we can do the rest of this in here. So if it's greater than 9, subtract 9. Okay. So cool. So let's say check if greater than 9. And then maybe underneath we'll put subtract 9. If so. And then maybe we'll put on the outside here. So we can double these numbers. We can grab the number, we can double it. But ultimately, we need to put it back in place. We need to make it stick. So we need to actually change that character. And so, we might want to say something like save new digit or something like that, where we're actually saving the value so we can put a new number back together, because we are going to get a different number than we had previously. All right, so we might want to do that. And then after we have that piece, we don't really have much left. Cool, we have everything. Maybe we now want to return new number that we got after we did everything here. And the last thing is that we want to add all these things up. And so maybe we want to loop through digits. Okay. So begin loop through digits. Add each digit. Actually, maybe we want to initiate a sum counter. We want to keep track of everything that's going to be, like, what the total value is going to be. And we're going to say add digit to sum counter. So we want to track that along here. And then we want to check, once it's done, if sum is divisible by 10. And then return true if so. False if not. Okay, this is some basic pseudocode that can help me. This is some basic pseudocode that may can help us through. This is not amazing pseudocode at all. Just wanted to take you through the practice of trying to implement some pseudocode on a page or something like that to show you that it's not actual code, that you're kind of free to kind of make it work how you want to make it work. I didn't even do all the variable stuff and things that I should have done, but yeah. Do you think 32 gigs of RAM is too much for front end and back end development? I mean, so I'll be honest with you, there's no such thing as too much RAM. If you have the money for it, I say go for it now so that you can do some other stuff if you want. No, especially if you're gonna, I mean, you definitely don't need that much RAM for development. You don't need that much RAM for development. But ultimately, if you want to dive into some bigger things, maybe one day you want to run some Kubernetes clusters or something on your machine, or you want to run a bunch of containers or something, it might be good to have. I wouldn't, yeah, you don't need 32 gigs of RAM, okay? If you can afford it, go for it. That is exactly, if you can afford it, I say go for it. Better to have more than enough than not enough. I find, so I was thinking about this earlier today. Let me just throw this out here. For something like your computer or your phone, or even like when I was at the store, these graphics cards, these processors, someone was really struggling in their heart. They were really trying to figure out if they should spend $650 for the 3950X or $799 for the 5950X, the new one that had better, whatever. Now, he made the claim that he had the money. He made the claim that I want to save money if I can, but I don't know if I really need to. My thing is, this is something he said he gamed all the time. If you're gonna be coding a lot, if you're gonna be utilizing this computer very, very often, and you're gonna keep it for a while, over the course of 2 years, that extra $100 difference, I think is relatively negligible. If you have it to spend, I think it's negligible. I think you should go up for the peace of mind. I would go at least 16 gigs, to be honest. But yeah, just throwing it out there. If you can get it, I say get it. It opens up your world to a lot of cool stuff. 16-inch Mac, 16 gigs of RAM is not enough. I mean, yeah. I mean, well, the new, I'm interested to see how RAM management works on the new M1 stuff. It's pretty interesting. I'll check it out. Now, large company, we run all our local infra on VMs. 16 gig barely covers it. Yeah, for that, 16 gigs ain't it, Chief. And when X will be a game changer, I agree. Might stick with 16. Yeah, I agree, White Wolf. I'm probably going to get a 16 gig version when that comes out. Also, from the pricing of it, 32 gigs might cost a laptop. It might cost $400 to get 32 gigs. It might cost $500 to get 32 gigs on the new M1 chips. So we'll see. But I'll probably only get 16. But I pretty much stamped it. I'm definitely going to, my mobile development work, my mobile workflow is going to be all Apple. My desktop, everything at home is going to be Apple, it's going to be Windows, Android. So, living all the worlds all at once. Okay, so now we got our pseudocode here. Let's go ahead and let's try to implement some code here. Again, every time I do this, I do not have this project memorized. I have done it before. I've done it at least twice in 2 different ways. We'll just try to solve it. We'll see what comes out of it. Again, for this class in particular, I'm going to be pretty verbose in what I do. And then if we have time to optimize it, we can optimize it afterwards. I think the verboseness really does help in, for people who are just learning right now. I think it's going to be perfect. Being as verbose, maybe not as verbose as possible, but pretty verbose makes the logic easier to understand as you're going through it. So what's up, Sully? No, I'm not going 64 gigs and don't look back. I mean, yes, for Windows, absolutely. Yes, for affordable 64 gigs of RAM, yes. But that max 64 gigs is about to be a monster. I'm not ready for it. I'm definitely not ready for it. What's up, Marala? Welcome to the channel. Joshua Toast, good to have you. Da Vinci D, welcome. Good to see you all. Do it, no matter. Yeah. I can't do it for a Mac. I can't. All right, so I'm thinking about, I'm I'm really thinking about going Threadripper and 128 gigs for, I mean, I want to, for no reason, for literally no reason. It would not help me at all. Again, I'm thinking about the future. Maybe I could use it. Maybe I can figure out a way to utilize it. I can't. You tell me with another exercise problem. I've been tackling that strings that replace method. Yeah, there we go. Perfect. Yeah, there's definitely a replace method. Again, I didn't know what it was called, and I don't know if that's the one there's a couple of them, I'm pretty sure. But whoops, I typed that into the wrong thing. I was trying to go into insert mode. That's what that thing is there. All right, so let's go ahead and let's do this. So what I'm gonna do first is I'm gonna write, all right, I'll set up the actual thing that we need to, the function that we need to run, that's gonna be testable. I'll set that up first. That's probably the best way to start. So func, it said it was called valid, I think is what they said it was called. Yeah, valid is the name of the function. Okay. What? Whoa, clear. Let's get back in there. Oh no! Another key came off. That was kind of weird. Whoops. All right. Ignore this. Cool. Let's open this up. And func valid is what we want to mess with first. What's up, KMRN90? What's up, Made Belief? Welcome to the channel. We're just doing a little bit of problem solving here. So let's go ahead and create this because it's the function that we need. They're going to pass in a string. All right, actually, let's open this up side by side because we are going to need this to be able to set this up. All right, so they're going to pass in what? The test input. I need to go look at test input, valid, fatal if, test input, test description, test okay. So they're going to pass in, that's into the test valid. They're going to pass in a string. Okay, so they're going to pass in one thing. I'm going to set that up. So the string they're going to pass in, I'll call it str. I'll call it string. What's the output of this? What are we returning? We've already seen it. We're looking, we're gonna be passing back true or false values. So we're passing back a Boolean value. So we have that set up right now, okay? The very first thing that we wanna do is make sure that we can clean up this input. We can ensure that it's valid to run. So the very first thing that we can do is let's create a function that will allow us, let's close this, we don't need this anymore. Let's write a function to ensure that we can clean this thing up. So I'm gonna write a new function up here and I'm gonna call it I'm gonna call it validate string. I'm gonna call it validate input actually. This is gonna validate our input. It's going to take what? A string. We're gonna pass the string that we just got in. We're gonna pass it straight to this function. And maybe, out of this, I guess we can also give a Boolean value back, okay? We can determine whether it is true or false by passing a Boolean value back, and then we can handle that in our main function, okay? So let's talk about cleaning up this input. All right, let's do the very first one is length 1 or less is invalid. So we need to check for length first. Maybe this is not the first thing we should check, but it's the first thing we have here. So let's write the code for it. How do you check for length? We can say if length of, what are we checking the length of? We are checking the length of S. The length is going to be how many characters are in this thing. So, you know, as long as it has one, as long as it has more than one character in it, it's good to go. So if length of S is less than, so you can do this a couple different ways. You can say greater than or less than or equal to 1. Then we have a failure here. Everything's, you know, this thing is not correct. It is a false value. It is not a valid input to our stuff. So we could do something like this and we could simply return false immediately. And that would determine that this thing is no longer valid. So we could do that. That should work. We'll check this out in a second with that. Let's see. Mentoring AI Lun on the side. Dope. That's great. That makes me good to hear. Got a Linux Bible. That's dope as well. I did check out, Sully, I did check out the Linux Bible. I haven't gone through all of it, but I did check it out. I do want to go through it because there are some things that I want to do with Linux because it's been so long since I've like spent like all of my time in Linux. There's some things that I want to learn about Linux. That's pretty dope that I don't know. That's cool. That's amazing. Hooked on a 49-inch monitor didn't help either. That the ultra wides are problematic. Here's my dilemma right now. I have an ultra wide in the office. It's not 49, it's 43 maybe. I don't know what it is. It's not the 49-inch one, but I have that one in the office, which I love. But it's like it's the 1440p equivalent. But I in front of me though, I have two 144 hertz 4K monitors and 27-inch, and I can't like hertz the refresh rate and G-Sync is what I love. It's better than the ultra wide. I don't know, it's weird. I need someone to combine both of the two for something that I could possibly afford in one day, because that stuff is super expensive. What's up, pretty boy? Good to see you. First time here. Welcome. Come on in. You've come in on deCoded day. You know, we're doing computer science and software engineering concepts. Today, we're just talking about problem solving and learning how you would approach a problem. Not necessarily giving you all this. We're not going over all the data structures and teaching you how to do every algorithm. That comes a little bit later. We're just talking about how to approach these things. The LG one is too big. It's a TV. It's 48 inches. Like, I can't use that. Like, I've checked that out. I looked into it for sure. I can't use that at all. Thank you so much for the follow. I appreciate it. All right, so we have our first little validation right here. We check if the length is greater than 1. Basically, we say, hey, if the length isn't 1 or isn't greater than 1, if it's less than or equal to 1, then this is a failure. It's false. Okay, so I'll leave that in there. Maybe we can optimize a little bit later. Again, let's be very verbose. Now we need to do the piece where we strip all of the spaces. And this is where I want to tell you why it's more important to know what to do rather than exactly how to do it. You can solve this problem if you do what we did here by doing the pseudocode and figuring out how you might want to structure it. We could Google whatever we wanted with any language. If I didn't know how to strip spaces in Go, I could Google, how do you strip white space in Go? I could do it with Python. I could do it with Ruby. I could do it right now with Haskell or something. I can say, how do I strip white space in this language? And you could go find information about how to do that. No problem. So let's do exactly that. I already know that there's something in the strings package, but just to show you how you would approach it, you say, hey, how do I strip white space in, and look at all the languages that come up. Look at that, in all these different languages right here. And we're gonna say go. And it's cool. And this is how you learn. This is why I said the act of attempting these problems, setting a time limit for yourself and attempting these problems is super duper helpful. That's a good picture. I feel like I wrote this, even though I didn't. And it shows you some different ways to do it. So the strings trim space function removes leading and trailing white space as defined by Unicode. So this might be helpful to us. We know that we have spaces in the middle. But this does leading and trailing, so that's cool. What else do they have? They said 3 ways to print, but they only show us 1. Okay. Oh, so to remove leading and trailing, this is a lazy article. To remove leading and trailing characters, use trim. To remove only the leading and trailing characters, use the, okay, so that's not helpful for us. But the strings package is where we're gonna wanna go. Trim all white space from a string. Let's see if this is useful to us. Different methods for doing it. They have a if Unicode is space. Oh, so we can check if it's a space. That seems like a lot of work. Space map, cool. Now let's go to the documentation right now. Let's go to godocs.org. And it's in the strings package, and there are a number of replace options here in the strings package. That is why, if you do want to learn Go, you should get familiar with the standard library because it has a lot of cool stuff. The more and more you know about the standard library, the easier it will be for you to solve problems. But they do have, replace here, replace and replace all, okay? They have all this stuff here that we can use. Replace, let's look at the differences between them really quick. Replace returns a copy of the string S. So replace, this is how you can read this documentation. I don't think we went over this that well. They give you the function signature, okay? We are familiar with function signatures, all right? So this is how you can read it. The function replace, when you use it, this is what's getting enacted. The function's called replace. It takes in S, old, and new, which are strings. So it takes in 3 different things. whoops, which are all strings, and it takes in, which is an integer. So it takes 4 arguments. That's a lot of arguments, and it returns a string. All right, and then it gives you an example of what that looks like. So if we wanted to replace oink, oink, oink with the old, that's the old string. No, that's the string itself. Old, the thing that you want to replace is K, and you want to turn K into KY. If you play that, it's oink, oink, oink turns into oinky, oinky, oink, because it only is gonna replace K with KY, but it's only gonna do the first 2 because of this. All right, so replace will tell you how many iterations to replace. So a little bit confusing, but replace all, a little bit easier. It takes in 3 things: the string, the old string, the new string, and returns a string. So it's without the number because it replaces all stuff. Sully, I caught it. I definitely caught it. I thought it was very interesting that they used those 2 letters. But again, I'm a grown up, kinda. I'm gonna keep moving. Sully, I'm with you. I told you. This is what every day I might start recording all the stupid things that I laugh at throughout the day, and just to tell people that you don't have, it's okay. It is okay for you just to be a child. Okay, I'm a child. That's simple. All right, so replace all is what we're gonna use to kind of get everything out of the way. Is this the most effective? I don't know. It seems like it's gonna be the easiest thing to use right now, just to get all of the spaces gone. And so let's try to use it. Okay, so we gotta import the strings package. So let's go ahead and first let's import the strings package so that we can use it. And we are going to make our first import statement. And let's go ahead. We're probably gonna have to import more, so I'm just going to make it a collection of imports. And now that we have this, whoops, I didn't mean to do that. Now that we have it, let's go ahead and let's do, we need to replace all of the stuff. So we have a string, and what we're gonna do is, now the question is, we need to save that. So we're gonna say clean string. Okay, maybe we're gonna do clean string is now equal to strings dot replace all, which I think was the thing, and it took 3 different things. It took the original string, it took the old string, which was a space, and I want the new character to be no space at all. Okay, and I think this is it. S, the old string, and what you want the new string to be. So cool, there we go. So we'll do that right there, and this should replace all the strings. And so let's be very clear about that, so people know what's happening here when we push this up a little bit later. Remove. We'll say here's where we are stripping all spaces. That's what we're going to use for this, okay? And then on this one, we're going to put up top here, checking if length is less than 1. Okay, cool. So I'm gonna remove these 2, and the last one is to disallow non-digits. Okay, so the order in which I would do these, actually, and we can talk about this. The order in which I would do this would be I'd probably strip it of spaces first. That'd probably be the first thing that I would do. Because because a space is a character, I'd probably strip it of that first before I check for the length. Then I'd probably check the length next to determine if it is even eligible for us to go through at all. And then the last thing I would do is probably disallow the non-digits to go through and check for those. So let's do that. Yeah, let's paste that here. Cool, there we go. What about different white spaces and tab characters and new line event? Latero, yes. So all of those things matter. All of those things would matter when you're solving a problem. But what I want you to take into account, this is very important. This is very, very important in understanding what the scope of the problem you're solving is. Yes, that is usually my first thought. Like, especially if you're working at a company, hey, those are questions you should ask. Do we need to care about white spaces? I mean, all other kind of white spaces. Do we need to care about special characters? What about all of that? They've given us a structure that we can kind of expect, and we also have the test cases to go through to kind of make sure that we can pass them. Sure, if you wanna get whatever you want to do extra is great, but we want to make sure that we solve what they've given us. And so I don't think we need to handle any of those right now. It doesn't look like they're checking for any of that, and they haven't mentioned any of it in the stuff. But the website is, so I went to godocs.org because that's what I'm used to going to. It now heads over to package.go.dev, and it's their new like documentation site. But I still, out of habit, I still type in godoc.org, and it simply just, you know, redirects me to here, because that's where I'm used to going. All right, so we'll put that first. We'll get all the white spaces out of there. We'll check if it's long enough, and then we will. The last thing that we'll do is we will do the other part. So this part can be pretty difficult. I actually don't know, like offhand, I don't know the best way to do this in Go. Let's just talk through it. We need to confirm that everything in the string is a digit. So there's a couple different things that you can do here. The most verbose of things, okay? The most verbose thing you could do is to do something where you would create a collection of all the digits. So you might create a collection of 0 through 9, okay? And then you might loop through every character in the word and check to see if that character is in the collection of digits that you have, okay? That's something that you could do. That is the most verbose way to do things, and it is a valid answer to this. That is essentially what needs to happen. Usually languages have something like this built in. I believe that Go does. So I'm gonna check the strings package. I don't know if there's one in the strings package. I think there's like a strings like .isDigit or something like that. If there's not, I will Google it and I'll find out whichever function it is. Yeah, so we could do that as well. We could try to convert it. To a number. So yes, we could do that. But something we just learned about was error handling. We'd have to do a little bit of error handling to make sure that we caught it in that case. Yeah, we could do that. There's a function inside of Go to do this. Let's see. Not this. It's like a UTF package. Let's see. A Unicode package. Unicode, decode. Let's see. Go. Check if digit. String is in, so you could do this. I know there's an easy one. Check if string is a number. Yeah, we can try to convert it, I guess. I thought there was an isDigit type function in here. We can try to convert it, that's fine. But then this is exactly what I was talking about. Then we got to add a little bit of code to do some error handling. I was trying to do it in the easiest way possible, but it's okay. Looks like that's going to be the best way to do it. Or that's the way that people are telling us to do. Oh, wait. Unicode isDigit. There is a Unicode one. This is what I was talking about right here. So not this. Not the Unicode UTF-8, just the Unicode package. I knew I'd seen it before. In here somewhere. And so it takes in a rune by default, which is great. So it takes in a rune and determines if it's a Boolean value or not, okay? So isDigit reports whether or not a rune is a decimal digit, okay? So how would we do this? Let's go ahead and try to use this. So let's import the Unicode package. And let's see what we can do here with this. Import Unicode. And underneath here, we'll do we need to first go through each letter we need to loop through the entire letter, okay? The way we can do this is we can do for I in the range, Can you do for I in range for this? I think you can. For I in range S, I think you can do that. Let's actually check the other stuff. I wasn't sure about the scope and why I asked about negative numbers. I'm sorry that I missed your negative number item. Oh, interesting. About negative numbers being put in. So negative numbers, would there be a negative number in there? That's actually a really good question. We can check the test cases. Definitely check the test cases if we want. If it's a long number, it should return a digit. Oh, so you're saying just check the entire number? Yeah, we can do that. We can just do the entire thing. So here's the problem. Okay, that actually makes a lot of sense. SimCity, that's a really good idea. So because I'm trying to think about this in the most verbose way, I really wanted to go through each character to kind of confirm that. And that's what I was going to try to do. But SimCity has brought up a really good piece of optimization. The good piece of optimization here is that so we won't be able to use isDigit, but we will be able to use the conversion function. We'll be able to use the Ascii to the Ascii to integer function to do this, because if we've stripped out all the spaces, no other characters are allowed. If we stripped out all the spaces, if it's a number, it will be one complete number. So that is another option as well. We could do that as well. About the same amount of code, to be 100% honest, but probably a lot faster. Yeah, probably faster as far as the code is concerned. Let's do that. Just simply because we have to do some of that error checking in here. So instead of using this isDigit, because the reason why we can't use isDigit is because isDigit is going to take in a rune. A rune is simply one of those characters. We can't use isDigit, all right? Because we're going to pass in the whole collection of these things. All right, so we can go back and we can use the string conversion package. So that's the package that's going to allow us to do some string conversions. And there is, again, you all help me with this, I will never forget it now. We can use the Ascii to integer function to allow us to do exactly what we need to do. What's up, Candy Boy? Good to see you. Hi Ray, welcome to the channel. Jen, welcome as well. Smokey the Bear, welcome. Roman, good to see you. Who else we got? Let me scroll down a little bit. That's everybody. Good to have you. But yeah, so we can go over and take a look at what happens when you try to do a string conversion. The Ascii to integer function will allow us to pass in a string and determine if it can be successfully transitioned into this thing or not, into an integer or not. Super helpful, so we can use that really quick. Mr. CM Griffin, thank you so much for the raid. Shout out to CM Griffin. You all know about Mr. CM Griffin already, but great person, does build some really cool stuff here on Twitch. Real chill guy, spends a lot of time on here. I'm jealous. I'm trying to catch up to you. I won't ever catch up to you, no chance. But good person to learn from as well. Thank you so much for the raid. Hope you had a great stream today. Welcome everybody from CM Griffin's channel. Come on in. We are simply going through we learned how to a structure for solving problems, or for how to approach problems, and we're now just putting it into action, and we're just going through and we are tackling a coding challenge. We are tackling the Lun's algorithm off of Exorcism. So you can hop into exorcism.io and grab the Lun algorithm if you like. We're getting through it right now. So let's go ahead and do that string conversion. Now that we have this clean string up here and we know that it's longer than one, we can go ahead and try to do this, implement this function. And the way that the function goes is we capture it to another value. But it returns two things. And so if I actually go down to where it is, it'll show you that it takes in a string, which we're gonna pass in, and it returns both an integer and an error. And so we need to check for the error and do some, we can do this one. We can do this one-liner right here. Let's do a one-liner. No, I'm gonna be verbose about it because again, we want to be clear about what we're doing. So we'll save it to is valid, okay, or error. We don't really need it as is valid, but it's fine. You need to fix your if statement. If length of s is less than or equal to 1, return false. What's wrong with that? Oh, sure, that works. Yeah, thank you. Good catch. Because we moved it around, because we turned it around, you are absolutely correct. Got it. We had it swapped at first, and then we switched them around just to kind of make it a little bit cleaner. All right, so we're gonna take this, and we are going to invalid error equals what's it? strconf. Oh, I haven't imported it yet. Let's go ahead and import it. This new package, and let's get down to line 20. And let's append to the end strconf and dot, again, ATOI, because now I can remember because of you all are so great. It takes in a string. The string that it's going to take in is our clean string, okay? Well, that did not work. Clean string, tab. It's going to take in clean string, and it's going to attempt to convert it. All right, that's going to return either an actual value or it's going to return an error. This is where we can now take in the error. All right. I've already said you don't have to stream 40 hours per week, but I want to. That's dope. You know, there's nothing wrong with it. Really, there's nothing wrong with it. You know, I just skip stream prep part. Yeah. First time catching up live. Dope. Catching up with the YouTube channel. I love it. I definitely do love it. All right, so we can now do the conversion of this. If it can be converted successfully, we know it's good. If not, if there is an error, we can, we can return false. So this is probably, again, not the most idiomatic Go. We probably should have created an isValid variable to track this through, maybe, but whatever. We're just gonna get it going. And so what we're gonna do is, now that that's gonna come back, we're gonna do exactly what we just learned. We just learned this on Tuesday, okay? We're gonna check if the error is not nil. So it should come back as nil if there's no problem. All right, so if error is not nil, then we need to do something about it. That's when we need to return false, okay? So this is kind of gonna suck, actually. I wonder if I can just toss this value away. Let's see if that works. That should work. So return nil. If not, the very last thing that we need in this function is going to be a return true. This is gross. I actually don't like this at all, but I want you to see what's happening. Before I clean it up, I want you to very clearly see what's happening here. Big hug from Portugal. Big hug right back at you from Baltimore, Maryland. It's good to see you, Pedro. Welcome. Come on in. What's up, OG? OG Double Nickel. I like it. Good name. Welcome to the channel. It's good to have you. So what is this validate function doing? What's happening here? First thing that's happening is we are taking in a string. We are first cleaning that string. So the very first thing we're doing is running a replace all. We are removing every single space that is in here. We are replacing it with a non-space. Replace all will do it to every single one. Big hug from London, England. Welcome from across the pond. Again, the biggest hug right back. I love that people are passing along the hugs. I can feel them. I can feel them. You know, hopefully you can feel the love right back. Just very friendly hug, even a socially distanced hug. Okay, you know, welcome. It's good to have you. I'm on vacation, but I'm having a lot of fun helping here. Dope. You know, I'm always down for the help. It's super helpful. Okay. So we'll check this. It'll remove all the strings. Great. Once we get past here, once we clean up the string, we will now check its validity by making sure that it has a length of greater than 1. So it can't be 1, it can't be 0. It's got to be greater than that for this to be good to go. So we're gonna check that. If it is less than 1, it will return false. Less than or equal to 1, it will return false, and that will drop out of here. It'll never get to the code down here. Now, the last piece is that it's going to check. It's going to attempt to do a string conversion for an Ascii to integer function here, and it's going to try to convert our cleaned up string to an integer. This is how we can do this, because it will confirm, if it can be done successfully, it will confirm that every character that is in here is a digit. Okay, it'll confirm that everything here is a digit. And so actually we do not want to return, we might need to return something different. Okay, we might need to return something different, because we want to use this cleaned up string. I think we want to use the cleaned up string, so we might return that. Okay, we might return 2 items. We might return the string and the value, but we'll see about that. For readability, it would be better if it was a new function. I agree. So you're saying the return? Are you saying the conversion should be a new function? And I'd be interested to start doing some. One day we're gonna do some voting on that. The convert to digit. Sure. Okay. Why do you? So question: do you also think that every piece of the cleanup should be? Okay. I think that makes sense. Validate it first because that validates it a little bit. Cool. Let's do that. Pretty easy to do. Let's close this off. Right here. That's all we got to do is close it off and give it a new return, and we can return the bool. Okay. So we can simply return, if it makes it down here, we can simply return true. All right. So that's how we know that the input is valid. Okay. We do know that it's valid here. Actually, no, we don't. We need to first. Now, the question is now, where do you want to call it? Okay. Because you have a bunch of nested conditionals. I don't have any nested conditionals. I don't have any nested conditionals. I have two separate conditionals. Two separate conditionals. I don't have any nested ones. So now the question is, if we put this into a different function, which I think is completely fine to do, where do you want to utilize this function? Now it comes into the part of where you think it's better to utilize the function at. Do you think it's better to, we have a function that's kind of dedicated to validating this. We could change that up a little bit, but should this simply be called in the validate function? Should the validate function be done to kind of just clean it up first and confirm? Like there's a lot of options here. I'm just asking where you would want to call the conversion function. Where should we do it? But just one step you need before you check but it's just one step you need before you check the other conditions. Which one do we need before we check the other conditions? I'm a little confused, but no, let me first, I'll spread it out a little bit and then just let me know where you think we should put, where we should call this at. All right. And so let's close that off and let's make this into its own func. Convert to int maybe, and this is also going to take in a string. Let's see, afterwards you have to check if the double digits and subtraction part correct. But the problem is, so yes, that's true. But then that means we have to put this validation, like we can do it there, but we have to do a validation. That means we have to do a validation step if we do that. If we put it in the part where we're actually doing the math, this is still, we have to confirm that everything in here is a digit. So if we put it in the part where it's going to do the math, where it's going to start to double stuff, if we should do that, then we're going to have to put in a way for us to return to break out of the whole code, to break out of everything. We're gonna have to tell it that this is no longer something that we can do, and so we're gonna have to add in a whole extra paradigm to that. We can do that. I think that's a little bit weird. That means the whole function will return true. So yeah. So that's fine. Yeah. So if we use the ACOI, that means the whole function will return true, but I think that's weird. I think that's weird logic to mix. Also, code val, Aya, if you're on here, thank you guys so much for the registry purchases. I really do appreciate you. Seriously, want to make sure as I see them, my wife shows them to me. I don't really check the registry. I'm gonna be 100% honest with you all. Thank you so much, genuinely from the bottom of my heart. I really mean that. I didn't want to go past it at all. The convert function should be named isDigit or something that's not actually converted. Okay, cool. That's fine. Yeah. Okay, that's fine because that's what we're doing. But again, where do you want to call it at though? If we're gonna split it out, I'm just where do we want to call it? Do we want to call it where we're validating these things, or do we want to call it in another place? and I can see some of the oddities up front. So we can put this in an is digit. I think it's good placement there to just be called here. Okay. Well, so the problem is yeah, Latero, this is what we already have gone through. If we should use the Unicode is digit, agreed. Oh, Unicode 8 is digit. Let me check that out. Well, no, that's still going to take, even Unicode 8 is digit. It's still going to take, what does it take in? Does it take in a, we went to Unicode already, and it takes in a rune, which means we would have to loop through each of these characters. Oh yeah. I'm not done typing it out yet. But yeah, so in Unicode, there is this is digit in here. So we don't I don't think we want to do that. Great. Brandon JC, 100%. We're gonna have to return it in this function. We're trying to go through for the main valid function. We're gonna have to return it 100%. We'll probably have to return 2 things here. No problem. The question is, yeah, it looks like a couple people wanted us to break off the digit check into its own function. I'm completely fine doing that. Checking for if it's an is digit on its own. Yes, I'm completely fine with this. I just want to know where we're gonna call it. I guess if it returns true, you will use that func valid. I got confused, so it'll work. So the problem is that the ATOI doesn't return true or false. The ATOI, oh wow, thank you. Good time check. The ATOI returns, I don't think it does. Does it? I thought ATOI returned, maybe that's my misunderstanding. I'm pretty sure ATOI actually returns the converted value rather than the true or false value. It returns the error and the actual converted number rather than true or false value. And so let's check that out just to make sure. I got to get out of here in around 15 minutes. It's okay. I'll get out of here. I'll make it work. So let's see. I think the validate input should have multiple returns. Yep, it'll have multiple returns. I agree with you there. But yeah, so that's ITOA, but even ATOI should return the actual. Yeah, it actually returns the actual number. And not a true or false value. So I think if we split it out, we're still gonna. I think it's weird to split it out personally, because the goal of this piece of function is a bottled up piece of validation. But yeah, sure, I can call it in the. Okay, I can call the function in the if statement. So you're saying call. So you're saying the last check right here. Let me just make sure. We're all on the same page. Is that you want me to call the is digit function right here? So I'm going to create is digit. I'll call it here, and I will call is digit on the cleaned up string. Okay. I'll call it on the cleaned up string. It will return. In this function, I will have to return a value, probably true or false. This seems like extra to me, but we can still do this. So what do you want? I guess what do you want me to capture? If we split out this function for the is digit, what should I capture? So I can return a true or false to determine if it's true or false. I can also simply return. Yeah. See, I'm gonna. That's very interesting. Are there more things to validate? No. This is the last piece of validation. The last piece of validation is checking if it is a completely it's a completely numeric item. I don't have anything else that I need to do it. Return is digit. Okay, so we can return is digit, but what does? Okay. Returning is digit though. We need to get out of this. We need to get back more than a bool. We need to not only get back a bool, but we also need to get back the we need to get back the cleaned up string as well. Okay, so we need to get bool back, and we also need to get a clean string back. All right. The problem here is should we receive, if we do it this way, we can return back isDigit. What we'll have to do is, for the application to know that there's a problem with what's returned back from this being false, is okay. That's fine. Yeah, that's fine. We can do that. I think we're gonna have to add in a little bit more handling, but that works. So you're saying return isDigit clean string as well as clean string. We can do that. Okay. I think we're gonna have to handle a little bit more doing it this way. This feels more complicated. It's a validation function. You should return a bool. I agree. I agree with you. If it's valid or not, I do agree. I agree with that. And I agree. But we also need to, so then I think it makes a little bit more sense to actually remove the trim spaces stuff out of this, and then pass in the already cleaned up string if we want to do that, and then keep this as is. That might be the better option here. And maybe we don't even need a function for that. Maybe we just to make it a little bit cleaner, and more, or maybe instead of validate input, maybe we should call it something like clean and validate. Need to refactor and dry this code up when you're done. 100%, always. Here's what we'll do. We'll write a function called clean. Here we go. Now we'll just call that validate. We'll take this out right here. We'll take it. We'll leave this validation up here. And in the actual function that's going to run, the very first thing we can do is this exact thing right here. Okay. That's fine. I think that's okay. And so if we do validate input, the problem with returning isDigit, isDigit does not return a true or false value. So now, yeah, I'll change it again now that I removed that. The problem now is that because we've created this in a function, isDigit doesn't return a true or false value. We have to have it return a true or false value, which it's doing here. So return true or false. This will return just a Boolean. So we can take this out of here. We can return just a bool. And after we return just a bool, our validation is good. So it'll check the first one, then it will return return false, or it'll return isDigit. This feels, to me, this doesn't feel right, but I'm cool with it. I think it'll work. Unexpected declaration found on line 22. Oh, so you can't just throw out the first item. So this is actually going to be kind of weird here. So this is another problem. The problem here. No. So yes, it is. I hear you. isDigit is already a validation. So Latera, we're not. That's the function that we created. We can't use the isDigit that you pointed out because that will take that'll take an individual character. It will not take an entire string. I agree. We should have just made it work first. I agree. But this is why it's good. This is good to talk to though. This is actually pretty valuable. 100%. 100% be valuable. I guess you'd be right if you had a lot of validation to do. Seems like overkill. Yeah, it feels like a little overkill. But the isDigit is already a validation. It is one piece of the validation, okay? The problem is if we do it this way, the string conversion is actually going to convert this item, all right? And we actually need that item. So maybe I'm going to change it back because we need the value. Well, we don't actually need the value. We have clean string. We're good on that. The problem is it returns a value. So we have to use that value, okay? Like this actually returns a converted string, okay? And now we have to use that. And it's all good, City. This is good. No, this is definitely good. But I would be interested in seeing where you were going with this. I would definitely be interested to see where you were going with this. But the problem is here, if we do this, we get a converted string here. And if we have converted string here that we have to take in because that's what the ASCII to integer returns, we got to use this converted string somewhere, and we don't really need that. We don't really need that at all. So I'm just gonna take this. I'm gonna put it back I'm gonna put it back up here. I'm gonna take this. I'm going to take this. I'm gonna paste it. I'm gonna delete this line. And I'm gonna leave it like this, okay? Same functionality, one piece. It's gonna validate the input. We already have a cleaned up string, but now it is going to validate whether it is useful or not, okay? So a little bit cleaner. I think it's a little bit cleaner. And we'll see if this works. So this is the hard part though. I think this is the hard part. Now we need to do the other pieces. So this part that we have pretty fast, we need to double every digit from the right. That's very interesting. Let's do that. And we can do all these in their own separate function too. Let's create a function for this. Func. Actually, we probably just need a function. Now let's do all this. Let's do all this down here just to make it a little bit easier. And then we can make it more clean later. So we need to loop through this clean string. If it's valid, this will return false. First, we need to handle whether or not if it's false or not. So we can say clean string, should not replace all. We need to validate clean string. So we need to validate input. Validate input on the clean string. We need to make sure, whoops. Oh, what's happening? Validate input on clean string. And if we validate input on clean string, we are gonna get a value back and we need to return some data. So we can save this into valid. Maybe we can save that into valid equals this. This will come back as true or false. Maybe we can do right here. We'll do if valid, equals false. If it equals false, then we'll go ahead right here and we'll simply return false automatically because we don't need to run any more back. We don't need to do anything else. We just simply need to return false, okay? Actually, and we don't even need to do that. We can just do if validate input, clean string equals false. Then we can go ahead and we can return false. If not, we can keep going, okay? We can keep moving past this. It'll return false if need be. It says, hey, this thing is no longer valid. We don't need to do anything with it. All right, once we've determined that everything is valid, everything is good to go, we can now do our math here. So we need to first double everything from the right. How will we do this? And again, we'll write it. And if we need to move it out into a different function, we can. But the first thing we need to do is we need to iterate through the characters that are here, all right? So we need to do a for loop because for is the only kind of loop that's here. What are there's a couple different ways you can, do it. I think you can loop through a character. Can you loop through, in Go, can you loop through Go playground? Let me see. Can you loop through characters via range? Let's see. Let's check something out real quick. What's up, Ed Boy? How you doing? What's up, a white crab? What's up, Chalk? How you doing? Blizzard BL, good to see you. Ghost, good to see you. Should we reverse the string? We could reverse the string and simply move through it forward. 100% we could reverse the string. We could also go backwards through it because we know length and we know indexes. What's up, Ed Boy? Is that not what it said? Yeah, Ed Boy. This is what it is. It's Ed Boy. What's up, Ed Boy? I think we also have to convert the string back to numbers. Yes, we need to. We never captured a converted number, so we will have to. We will probably have to do that now, because we never converted it to a number to be passed back out because of the validation string. We could clean it again and convert the whole. No, if it's a number, we can't iterate through it. That's the problem. So we need something that we can iterate through. We could do a couple different things. Actually, we could reverse it. Right now, we could split it. We could split the whole thing. If we split it, it's an extra step. We don't need to split it. But if we did split it, if we did split this right now, what it would allow us to do is to have a collection to work with, and we could also replace it. I actually think splitting in this instance might be a good idea to understand what's happening. I think it might be pretty helpful to do. Let's actually, that's a good idea. I think we should actually do that. You're right, your number at the right index. Yep. If valid string split isn't better, if not validate input, sure. So Krizak, absolutely, that is no. We've had this conversation a couple times. That is, to me, and to I think most people, that is much less readable code. And right now we're just, because this is the apprentice level of this course, we are trying to, we're being a little bit verbose in the way that we're solving this, because I think, I will argue people to the end of the ends of the earth. I think that is not clean code, me personally. I also think that using any inverses, I think using inverses is a bad move. If you can avoid it, I would not use inverses for most people. If I wouldn't use not characters at all. If for clean code, if you're talking about clean code, yeah. So Latero, yes, we can use the range clean string. We can print that out. That looks right. I think we can use that. Now, if we do that though, if we should do that, there are two things that we have to do. Should we do that, you cannot replace a character, even though it has an index value, you cannot replace a character in a string that way. You can't reassign it a value. So should we double it during this process, we can't reassign it the value directly into the string. All right, so if we iterate over the string, we won't be able to do that. What we'll have to do is one of two things. We can either split it up into its own slice so that we can replace the value, or we have to create a new slice. Okay, so we'll do that. Can you cast it to a slice? We would have to convert it to a slice. So yes, both of those answers are right. We can do either one of those things. I think we can do. Let's add in a new collection. Okay, so let's do that. That's nice. We can do that and join them together. We don't even need to join them together. We never need to join them together. What we can do is create a brand new collection. So we can do a var of doubled nums. Okay, this is a bad name for it, to be honest, because all the numbers aren't going to be doubled. Oh, actually, we shouldn't do that. We shouldn't do it. So the problem is that we don't need to touch through the loop. If we do the for range, that would work, but then we'd have to put some handling functions, some handlers in there, an if statement to determine if the index was every other one or not. I actually think we should split this so that it's a single collection instead of multiple collections of doubled numbers and not doubled numbers. Or even if we stuck everything in there, we still have to put some handling stuff in here. I think we should split this function. I think we should do a strings.split on clean string. Okay, so I think we should do a split string equals strings dot, I'm assuming it's split, and let's see if that's actually a thing in Go. Pretty sure there is a split function, but I don't know what it's called. So let's go into it. Strings dot split right here. Split the string and the separator. So we don't want to separate it on, we can separate it on nothing, but it returns a collection of strings. So if we do a string dot split and we do that on the string that's being passed in is clean string, and we split it on nothing, it should give us each individual character returned. Okay, now this is now a slice of strings. Okay, it's now a collection of individual strings, which are characters. Okay, nice. We now have a single collection. We can work with the things in a single collection. All right, now with that, we can do everything that we need to do. I think. Actually, we can probably put this after. Let's actually yank this and let's put it after right here. All right, so we split it up. After we split it up, let's do 4. Now let's iterate over these things. We could do 4, we could do the range. We can do a range function, but let's be explicit here so that we know what's going on. Let's do a normal for loop so that we know what's going on here and that we can kind of understand what's happening. Zovek, thank you so much for the Twitch Prime sub. Thank you so much for the love. Thank you so much for coming in and helping. I appreciate that. Thanks for being you. Even as a vet developer, I learned a lot watching your stream. Dope. I love it. Yeah, you can do a mod 2 equals pass. I could do a mod equals 2 pass. No, I cannot do a mod equals 2 pass. Why can I not do a mod equals 2 pass? It's a good question. It's a good thought, but I can't do that. And the reason why I can't do a mod equals 2 pass is because the length, we don't, every other number from the left, from the right, it might be an odd indexed option. Or an even index option. It could be 7 digits, it could be 8 digits, it could be 2 digits, it can be 2 and up. So mod 2 pass will not work. I could do, yeah, mod 2 pass won't work for this if it, in the event that it is an odd number of items. So mod 2 won't pass. But what we can simply do is we can create a for loop. All right, so let's try this out. If we do, set up a normal one, let's set it at 0. Oh, let's not even set it at 0. Let's set it at the length. I is gonna be the length, our iterators is gonna be the entire length of split string, okay? Hold on. Delete. It's gonna be the entire length of split string, okay? If you iterate over the index value, it will be I mod 2. I don't think it. I don't think it would be. So let's say the item. Let's say the index value. Let's say the whole thing was 4. Let's say it was 6. It was 6. The index was 6. There were 6 items. So actually, let's say the index. Let's say it was 7. The length was 7. When you start, the index of the second to last item is actually 5. If there's 7 items, the second to last item is 5. And so if you do mod 2 pass, well, opposite, one extra. My numbers are getting off, but there's because they can be different lengths. I don't think you can ever do mod 2 pass, even if you're using the numbers. Because it's from the right. It's not from the left, it's from the right. You're starting from the right of the end of the collection, not from the left, okay? So if we're checking the length of split string, so for the amount of items that is in split string. All right, so if we have 10 items in there, we're gonna set up our iterator for 10 here. All right, how long are we gonna run this? Okay, we're gonna run this, I guess, for as long as, while I is greater than or equal to 0, I guess. We're gonna try to run this as long as I is greater than or equal to 0. Because we're gonna count down. We're actually gonna count down this time because we're setting this equal to the entire length, okay? And all we're gonna do now is we are instead, you know what we need to do? We actually need to do from length minus 2. There we go. So we need to actually do length minus 2. Why do we need to do length minus 2? All right, the reason why we need to do length minus 2, hold on, I dropped my pen. All right, the reason why we need to do length minus 2 is because if I have a collection of 0, 1, 2, 3, 4, 5, what is the length of this? The length of this is 1, 2, 3, 4, 5, 6. The length equals 6, okay? We need to start from, we need to go every 2 starting from the right. So we need to come in from this side over here. This is the 4th option. So we need to start at the 4th index. All right, we need to start at the 4th index. Even if this had another one, even if it had this, we need to start at the 5th index. So we need to do the length of this, which is now 7 minus 2, which will give us the proper index. So that feels right to me. So we started the second to last item. Minus 2 will start us at the second to last item. As long as I is greater than 0, that might need to change the I greater than 0. But now we will not increment at all. We will decrement, but we'll decrement by 2. Okay, so now we'll do I minus equals I. Minus equals 2. Okay, so now after we go through an iteration, we will subtract 2. Okay, but it's 9:06. I don't miss your thing. Penguin Airlines, I appreciate it. I'll be okay. I'll be all right. It's fine. This is more important. I was just trying to do my best to get out of here, but it's all good. I appreciate it. We're gonna finish this. We're gonna get through it. Right? We're gonna get through it. We have to get through it. We gotta finish it. So we'll minus 2 at the end. Okay. So we're starting from the second to last one, and then every go we will subtract 2. Now you probably can see that this is definitely going to give us I think we're going to run into an issue here. You probably can see where we're going to run into an issue here. We might run into an issue to where we get down to I equals 1. Yeah, you know what? Actually, I don't think we will run into an issue. We won't run into an issue. I don't think we will. Okay, let's do this then. All right, so let's, so this is our for loop. And now, yeah, there we go. That looks right. That's our for loop. Is it in it right with the -2? I think it's right. I think it's right. Again, this is what I was just showing over here. We need to start from, we're minusing 2 from the very right. We're starting with -2 from over here. So if the length is the length of this is 7. The length of this current one is 7. So the length of this one will now be 7. If we want to start from the one to the left of the last one, every other one starting from the right, it's going to be 2 less than the length. Not 1 less than the length. The index of this is going to be 2 less than the length, I think. Yes, since they are 0 indexed like they are in Python. It is 0 indexed. So let's see. Let's see how this works. And should that happen, I should have, you know what I'm gonna do real quick? Just so we kind of know something's happening here. What we'll do is, all I'm gonna do right here is I'm gonna format.println this, and I'm gonna format.println it in a way that I'm going to print out split string. I'm gonna print out split string, and I'm going to print out split string I. Okay, I'm gonna create a main function really quick, just so we can see it, working, so that we know, so that we can fix up some stuff before we actually get into the final product of this. Func main, we'll run this. We will simply call, what is this called? We'll simply call valid. And we'll call valid with, we'll call it with something like this. Wow, I don't know what that was. No, redo. I want that. And let's go F here. Let's see inside here. Let's call it with something like this. Okay, we're passing some stuff. And now I need to go to the top. So line 1, let's make this package main. All right, let's do this. Okay, so I'm gonna call it. I think this will work, except for this return something. I'm gonna return true here at the very bottom, just so I don't have to change the code here, because it has to return something. All right. Oh, there's no errors. I don't know how there's no errors, but okay. So let's try to run this really fast. And what is this called? This is go run lun.go. All right, we got a lot of stuff. Imported but not used, Unicode. Good, we need to remove that. Undefined clean string, undefined S, undefined thumped. Okay, so a couple of different things we can do to fix this really quick is first, line 1, we aren't using Unicode, that's helpful. Undefined clean string. Where are we calling clean string? Converted string, oh, right here. That helps. Converted string error. S. Okay. What were the other options here? Undefined thump. I need to add thumped to it. So undefined S and thump. So line 33 and line 42. Okay. Undefined S. That makes sense because it here it is str. And I need to add fumped right here. Great. All right. Okay, so converted string declared but not used on line 17. Let's fix the last, hopefully the last of the problems. Converted string declared. See, this is what I was talking about. If we use this for conversion and not looping through, that's fine. And it sucks because it won't let me throw out the variable. I don't know why it won't let me throw it out. Let me see. Go. Throw out var. Let's see. The blank identifier, I thought I could capture it with. I thought it would let me do that. Identifier, you can sign anything, but never read first example. I tried this, but it didn't let me do that. Let me try it again. Let me see if it works this time. Because I only want to capture the error, to be honest. And let's see if that works. Okay, all right. Let's see if that worked correctly. Let's look at what it shot out. It shot out 6, 2, 2, 3, 3, 5. 6, 2, 2, 3, 3, 5. 6, 2, 2, 3, 3, 5. 6, 2, 2, 3, 3, 5. Look at it from this side. If we go over 1, 6. We go over 2 more, 2. Oh, actually, 6, 2, 2, 3, 3, 5. That looks right to me. That looks right to me. All right, because it cleans it up. It cleans it up. So from the right, every 2 from the right. So 6, 2, 2, 3, 3, 5. We did it. All right, so this for loop does work. All right, so it goes every other after it's all been cleaned up. Okay, so that's super helpful. We'll have to convert this back. So after we are looping, now that we're looping through it, this makes it kind of easy now. Okay, instead of doing that, what we need to do is we need to set. We need to do split string. Let's do doubled num is now equal to, we'll set it equal to, we can't define it there. We can do double num outside of this. No, we just do this. If split string, we need to double it now, and then we need to do the subtraction. So if split string times 2 is greater than 9, okay? So if it's greater than 9, then what happens is we need to set split string. What are these? Are these integers right now? They're not integers, are they? This is not gonna work. Okay, we're gonna need to do some conversion here. So if split string times 2 is greater than 9, this is gonna be gross. Actually, let's do this. First thing we're gonna do is convert it in the for loop. First thing we can do is, no, we are gonna need another. Yeah, we need values in split string. Yeah. So we'll grab the values in split string like this. Actually, split string I. So we can grab the values like this. The problem is they're strings right now. There are 2 problems since we're doing this with Go. We need to convert them, and even if we convert them, we still need a secondary. We still need a second. We need a second collection. Or, yeah, we still need a second collection. Why do we need a second collection? Because this is a strictly typed language, and because this collection, so we can cast it, but then we can't save the value. If we cast it, we can't save the value. That's the problem. The reason why we can't save the value is because our current collection is a slice of strings. It is not a slice of integers. And this is statically typed language. What's up, Gimpy? Good to have you. What's up, Two Rice? What's up, James? Good to have you. What's that, Monsoon? Welcome to the channel as well. So that's another problem that we have here. Right now we are working with a collection of strings, and we need them to be integers. We could have converted them up. So actually, we couldn't have converted them up front because split doesn't work on that. You wouldn't be able to split up that integer in the same way we split up the string. So we had to actually leave it as strings. But now we need to do this. But all we got to do here, this is not a huge deal. To save this, we'll just create another collection here, and we'll say var updated ints. Ooh, actually, yeah, int slice append. This is actually a problem, because we can append it to this other list. We do need to change our. We would have to change this though. We would have to change this up, because we still need to append our non-doubled numbers. Right here, we're doubling the numbers. Our non-doubled numbers need to be in that collection as well if we want to add them all up. Or else we're gonna have to do some fancy magic outside of that. Let me think real quick. Let me think. If I cast it to an int, I can put it back in as a string. Okay, maybe we can do that. Maybe we can cast it as an int for the multiplication, but pass the value back in as a string. That's gross. Do you understand what's happening there with that? So can I do this? Can you just iterate over each character? Yeah. Rune and go converts. So do another for loop. Yes. Yeah, I can do that. You can assign a variable to a doubled number. Two separate lists you can add later. Yeah, but then I have to add it. So that's the thing. If I have two separate lists, then I have to do another for loop. I either have to do another for loop to populate the other list, or I have to change up the current for loop and put some functionality in there to determine whether or not it's every other number. And that is harder to do. That's much harder to do because it's not only even or odd. We can replace the value at the current index as a string, and then take that slice and convert it to an int later. Yeah, we can do that. Just one loop, iterate over the character in the string. For each character that isn't a white space, convert it to an int. We've already removed the white spaces already. So yeah, we could convert it all to an integer and add it to something else to give the numerical value. Do whatever you want with each int. A second thing. Let's simply convert them all to numbers really quick. That's probably the easiest thing. Just to do another for loop really quick. We have a collection right here. So let's actually, because we have a collection of strings right here, this is gross, but it's fine. Let's do for I in range. Actually, let's make a new collection. And so we're gonna say converted nums maybe, and we'll set converted nums equal to a var converted nums equal to a slice of integers. All right, we have to set up a new collection. We could do it all in place. It's possible for us to do it all in place without creating new collections. It would get really gross with the amount of transitions we'd have to do. I think this is a little bit cleaner right now. Again, we just want to solve it right now. Want to make it work first. So var converted nums is a collection. We simply do a for I in range split string. And basically what we'll do is we will do a converted nums equals append. We'll use the append function here, which takes in converted nums, and it takes in the thing that we want to convert it to. Actually, I don't think I can just cast it to an int. Can you just cast to an int? I don't think you can do that, but maybe you can. Let's see. Where's Go Playground? Let's see. What's up, Gaudutis? Good to see you as well. Welcome to the channel. Let's get down here. Format dot println. And can we just do something like int? And let's delete this. And 6. Does that work? If that works, this will make it easy. Yeah, it doesn't. We have to completely convert that. You need to be a rune. Unexpected. Hold on. 1, 2, 3, 4. 1, 2, 3, 4. Can I convert untyped string? So character, try single quotes. The problem is right now it's not a character. The problem is right now it is a yes. So that would work. The problem is right now they're strings. They're all strings. They're not characters. They're all strings. Yeah, I have to use ATOI. I was trying to do it without having to actually do a conversion, but it's okay. Completely fine. And so the way that we'll do this here is we will go strings dot eight. The problem is ATOI returns 2 values. No, Go has characters. It has runes. They're called runes, which is the character type. The problem is ATOI returns 2 values. But can't you iterate over each character in the string that you have? So yes. Yeah, that might be the ultimate way to do it. So if we do that, we have to switch it up a little bit. And that might be the way that we have to do it, because we went, yeah. All right. So this is what we're gonna have to do. That makes more sense. We can iterate over the range, over all the characters there. We were originally gonna do that. I thought this would be easier. It is not easier because of this exact reason. We instead can, this line where we split the string into its own individual things. Instead, we will range over the actual stuff in the character in clean string. So instead, for range clean string. All right, so this is gonna go through each character, and then I think I could do that. I think you're right. Let me make sure that works, and I'll show you all what has to happen should we do that. I do think that's probably the best option here. Int 6, and run this. All right, so here's the problem. If we do that, we still need, oh, actually this works fine. And we just delete this. Yeah, we just iterate over that instead, and we pass in int I. Yeah, I think that'll do it. 4_c range string. Yep. I don't even think I need the underscore, because I think the underscore would end up allowing it to grab the index. I don't even think we need that. I think that this will do it. I think this will do it, and it'll append it to converted nums. We can confirm that this happens. We can check this to make sure that it is working. By first, I don't think I'll need it yet. I don't think I'll need it because I'm trying to put it into the converted num section. I don't think I'll need it yet, and I'll show you why. Let's see it in action real quick. This is not Python. This is Go. There are easier ways to do this, but it wasn't working with Windows the other day. So let's go ahead and print out converted nums. Let's go ahead and print out converted nums right there. Who was Scooby? Thank you so much for the follow. Good to have you. Line 40. Unexpected. Found open. That's right. Line 40. Expected colon. Semicolon. Why would there be a semicolon on line 40? That seems, did that not seem wrong to anyone else? Because I didn't set it. Yeah, you're right. Okay. Thank you. The reason is because I'm not assigning it any values. I'm just setting it up to, yeah, sorry. This will be if I just set it equal to an empty, that would be setting it to an empty thing. Yep, got it. All right, so let's see this. And okay, so that gives us the, okay, I see what you're saying. All right, I thought this is the one that gave you the actual value and not the index itself. So you are correct. And so instead, we will need to, so we could also do this. This is not the best way. I think we can also do this. Let's stick the I in there. Let's see if that works. 52, 53, 52, 51. Ah, no, we actually, interesting. So that actually gave us the rune value. So that actually gave us the actual, are those ASCII number? What is that? Why not just underscore V? I thought underscore V was gonna give me, because then I have to use, maybe you're right, maybe that's right. That actually does seem right, because it'll give me the index. I can throw away the index and I get the value. That's fair. And just take the value here and do that. I think it's gonna give me the same thing though. Yeah, it's gonna give me the same thing. Okay, exact same thing. But now I need to do a character to get their 0 numerical value in the form, in int form. Do C0. Hold on. What do I have to do now? So append converted nums. What does this give me? Actually, I don't even know what's passed in. So these are actual characters, V-0. Okay. So you're saying right here, do if this is it, I don't know what actually. You're saying that? Is that a thing? If that's the thing, I have no idea what that is. I've never seen that in my life. You're saying that? Yeah. Okay. What is that? Oh, you got to tell me. I got to. What is that? What does that mean? I have no idea what that means. I'd love, if you know what that means, definitely let me know. I learned something new today. I told you all, I love learning from the stream because like I don't know what that is at all and why that makes it work. That's interesting. V minus. Wait. Oh, what was it showing me before? I don't know what my output was before. Let me see. Maybe I do know what that means. Nope. Don't know what it means. Okay, I'll keep an eye out for that for sure because I want to see what that means. And I'll look it up in a second if not. If you're not sure what it means, if you just knew how to do that, let me know. All right, so that's gonna give us the number. Now we have a whole thing that we can go through now. It's no big deal now. We have a whole entire thing that we can go through. So now this works now, okay? So now our for loop will work just fine, but we need to loop through something different. Okay, so instead of looping through the length of, we need to loop through the length of the converted nums, which is actually the same distance, that's fine. And then instead we can do converted nums here. Whoa, hit some buttons here. We're gonna convert the nums here. And now what we can do is we can do it all in one go now, all right? Think of a string as a collection of ASCII characters. Yep, we know that. If you subtract the code, for whatever the ASCII character, if you subtract the code for whatever ASCII character your own from 0, you get the difference as a number when casting it. 9 by 0 cast to an int is int. You can also do something. Okay. You're on from 0. I don't understand why the 0. I get it. I get it being a collection of characters, I don't get the -0 part. Let me stew on it for a second. I think that's a good explanation. Let me stew on it until my brain gets it. It's probably gonna hit me in the middle of this problem. So we can do everything all at once right now. We could loop through at the end and add everything up. I'm gonna add everything together right. No, I'm not, I can't do that. So now we're gonna go through every single item, every other item, and we're gonna double it, okay? So if, when you double it, it is greater than 9, then the current iteration that you're on, so converted nums, this is gross. You should use variables for this, but we're not going to because we need to finish. Equals, instead, we're not gonna append anything. We're gonna change this spot. It's going to equal converted nums times 2, converted nums I, all right, times 2 minus 9, okay? So if it's greater than 9, it's gonna equal double itself minus 9, all right? And if not, all right, so else, if not, it's simply converted nums I, the current one that you're on, is gonna now be equal to converted nums I times 2, okay? All right, so now this is going to change what's in the list, all right? And let's, here's what we're gonna do so that we can see this more clearly. I'm gonna subtract all the spaces from this, and let's see what this actually looks like now. I need to now remove this print statement. This print statement, I'm going to take it, I'm gonna put it down here so that it runs at the end of everything. And now we are going to run this, okay? So, I don't know what our original numbers were. Actually, let me print out our original numbers as well. Let's actually print out, let's be inside here, yank that. The first thing we're gonna do is format.println this. Quotes and paste that. All right, so we're gonna print out our number first so we know it, and we'll take a look at it. Okay, so this is our numbers right here. All right, so it's gonna skip this number. It's going from the right. It's gonna get over to 6. 6, if you double it, it's 12. 12 minus 9 is what? It's 3. So it replaced that number there. All right, skip again. We have 4 right here. Why is it 4? It's 4 because 2 times 2 is simply 4. So that fits. Go over again. We got 4 again. 2 times 2 is 4. We skip it again. We have 6 here. 3 times 2 is 6. We get another 6 here. 3 times 2 is 6. So the only one that it did something for was the first one. But I think this is good logic. I think it's good logic. Okay. So it goes through and it does all of that stuff there. All right. Great. Now we have a completed, validated thing. We've implemented the algorithm. We only have one more piece now. We have one more item that we need to do. Okay. We need to add them all up. We need to add up everything in here, and all we got to do is create a variable. We should make a function for this, but I'm trying to finish up. We should make a total item here, and our total is going to be set to 0. We'll set it to 0 for now, so that you can see. Now we're going to add up every single thing in this list. There might be a sum function. I don't know if there's a sum function. I don't know, but we want to be explicit about this. So for I, so we'll do the same thing we did before for everything that's in here. So for all the values in this, we're going to range over converted nums, and all we're going to do. Only thing we're gonna do is total plus equals V. All right, we're gonna add everything to that. Total plus equals V. At the very end, we will have everything, okay? We'll have everything, and then all we have to do is say if total, okay? Mod 10 equals 0. All we got to do is simply return true. All right. And then add an else. Actually, and then just do a return false at the end. So I'll delete this line. I'll return false here. And I'll push this, and then you all can make this better. Okay. And so I'm actually going to delete all this because this is not supposed to be here. Whoa. We'll delete that. All right, we'll go back up to line 1. We'll call this Lun again. I spelled that wrong. All right, I think we did it. I'm not 100% sure, but I think we did it. How can we confirm that we did? We can do a go test. Okay, I need to delete that real quick. What in the world is happening here? My keyboard is getting weird. All right, we didn't use it. Come on, go test. Come on, go test. We did it. We did it. It passed. Okay, it passed. So a lot of weird stuff there. We did it. We made it there eventually. That's why we should have made it work first. We didn't make it. I didn't follow my own rules, but I actually. So I think what we should start doing is sometimes when we do stuff like this, I think maybe in office hours we should talk about. I think it's a pretty interesting thing to talk about. Decisions and why something might be good or bad, because again, I told you guys, this is super subjective, and what you think is the right way to do something and what someone else thinks is the right way to do something is it really is subjective, and it can be argued either way. And I would really be interested in talking through why this is a better thing. And maybe we can, if y'all don't mind hopping into Discord, like it's probably easier to talk over it, like to talk through it. If y'all don't mind, if people don't mind hopping into Discord one day, maybe on the weekends, that's what we'll do. We'll do code reviews together, and things that we did during the week, better ways to do them. Share your own way that you built it and why you think it was a good way to go about it. I do not think this is the best way to build this at all. I do not. Not even a little bit. But yeah, we did it. We got it here. We got to an end goal. A little bit gross, a lot of for loops that we probably don't need. We can probably break this out into a bunch of functions. We can probably split out some of our validation logic. I'm gonna push this code for you so that you can get it, so that you can look at it, have it, play with it. Let's get it out there. Didn't we already have hold on, I think we have a directory here already for deCoded, right? No, we don't. Okay, well, I will take this. No, we have a directory. We have a deCoded directory, don't we? Is it in, or do we only have one for pipelines first? Okay, let's, I really thought we had one. Let's take this. What's the best way? I feel like I don't want to make a whole repo for this, but I will. It's not a big deal. Is it there? I'm confused. Is what there? I'm sorry. Or some of us. So yeah, we did it. We did beat it. Did you update your CSHRC? Yes, I did. It's not updated on GitHub. It is not updated. I did change it recently to use Rocket instead of pure prompt. So yeah, I do need to push that to GitHub as well. Let's go to GitHub and let's make a repo for this really quick. Man, I really thought there was one here. Let me start putting stuff in Academy. Actually, nope, that's going to be a lot there. Let's your repos. I swear, deCoded Q1. Yeah, we have this repo. Here's what I'm gonna do. I'm gonna clone this and I'm gonna stick it in here, and you all can grab it from here. I actually feel bad that I haven't been putting stuff in here. I will try to update this with everything we've done so far. Yeah, I went to this deCoded. It's not this. It's not that for some reason. Maybe we're working on a different server. So what I'll do is I'll git clone. All right. I will go into that folder. I'm going to, what week is this? MK this is week like 6? Week 6. Yeah, it's week 6. All right. All right. Did you guys just see what I just did there? That was bad. RMDir, week and 6. And MKDir week 6, copy, exorcism, go, lun.go, into week 6. That was a problem. All right, there we go. What am I doing? All right, so it's there. Excellent. Git commit, -m completed, Lun, algo, and git push. All right. Yeah, that's exactly what I'm trying to do. Get out of here ASAP. Yeah, share your hop in a Discord, share your own ways that you solve this. Again, we hop in. We just wanted to kind of touch on some things tonight. See if you can optimize it, see if you can make it see how clean you can make it. I actually really want to go through. I've never done this, like we've done this like this every time I've done it, and I've never done this cleanly. Like I've never gone through and like optimized. I really like to optimize and see, you know, how many lines of code you really need for this. It seems pretty interesting. I really think you could combine so much of the logic. I don't think it will be readable. I will stand by that. I do not think it will be readable, but I'm confident you could combine almost all of the logic into a pretty simple little section. So cool. That's it for tonight. What I hoped you got out of it is simply that you now know these different steps that you can use to be able to attack these things. Understand what needs to happen first. After you understand what needs to happen, make sure you comprehend it. After you comprehend it, break it down into little pieces. That's what we tried to do. We did a little bit of pseudocode, which wasn't amazing pseudocode, but we did some pseudocode, and then we coded it out. You can use this approach for any coding problem solving that you're trying to do. Make it work, make it right, make it fast. Don't do what we did here. Make it work first, then make it right, then make it fast. Get it down, get it comfortable, get it working, then optimize, then go back and change the things that you want to change. But that's it. That's it. I have a syntax there. I put mine on GitHub. This is the URL for it. Let me give you this. I sent it directly to this. So if you already have it, you might not need to clone it, but you should be able to just go clone it. It's in week 6, and it's the Lun algo. Should work just fine. Actually, in here, it doesn't look as long as I thought it was. What's up, Amame? You are late. We're getting out of here. You missed us. I learned, first off, I'm gonna go dive deeper into this. I understood what you're saying. I don't understand why it's 0, Scooby. I don't understand why it's 0 yet, but I'll get it. I'm gonna go look at it for 1 second. I told you guys, sometimes you need to hear it 10 times. And I'm like, oh, Scooby explained it perfectly. And I was just, I was just a little bit dumb for a little bit. What language are we punching with? This was with Go. We did this with Go tonight. We're doing both Go and Python in here, but it was with Go. A second had a good explanation as well. I'm sorry I missed that. I gotta scroll up right now. So because each rune is internally a value that's represented as a number, it's able to make the value of the rune 0 from the value of the rune V and return the value. This works because Ascii has 0 start at 48. Oh, so it offsets the value. Okay, that filled it in. Okay, as a zero start at 48, so it offsets the value. Got it. I got it. Second billing cycle. Thank you guys for putting that together. Thank you. You did it. You did it. I appreciate that. See, Scooby, together with second billing cycle, you guys did it. I'm not joking. You guys have filled in so many blanks for me. The A to I thing, the ATOA and the ITOA for conversion, ASCII to integer, integer to ASCII, that helps so much. That was very, very clear. That, boom, you did it. I'm just gonna be honest with y'all. Nobody's smarter than me. I am now, that's all I needed to know. I'm the smartest person in the world. No one's smarter than me. Thank you. I appreciate that. I told you, I need to add this to the list. There's some other amazing things that I've learned here. You guys taught me / versus \. I'll never forget it. You all taught me CD-. I've been using Linux for years. You all taught me CD- here. That was amazing. I learned so much. So much. I am Yeah, I'm the smartest person I'm the smartest person in the house, not just the room. The smartest person in the whole house. Okay. What's up, Jasmine? I am having a good day. I now need to go do what I was supposed to do and go eat, but it's all good. She didn't hear me. She didn't hear me. But peace out, y'all. I got to go hang out with my family. Who are we going to go over and raid and say hello to? I got to go do some work as well. I whisper when I talk about, yeah, when I talk trash, you got to, you know, it's okay. It's, you know, I'm never going to stop talking trash, you know, no matter what. But this was fun. This was good. Danny Stem, cool. We in there. I'm not even gonna go look. We're just gonna raid Danny Stem. You asked, you shall receive. She's coding tonight. Dope. I'll hang around for a few. I'm really just going to do work. I have so much work to do. so much work. Thanks everybody for coming through. Thanks everybody for helping out. Thanks everyone for sticking around while we got to the end goal. Learned a lot. Thank you for helping me learn. I hope you all got something out of it as well. Tomorrow we're back with tomorrow's gonna be a little bit boring for the things we've done. Tomorrow we're back with Horizons, which is a journey into cloud computing with AWS. That starts an hour earlier because it's once a week. And so tomorrow I think we're diving into stuff like CloudWatch and different monitoring and logging. So that's a little bit boring, but something you need to know for AWS. So I'll see you there if you want to come through. I should have called it boring beforehand, but you know, compared to doing what we did last week, it's gonna be a little bit boring. You know, but all good. Well, peace out, everyone. I will see you later. Have a great night. I should have hit the button 10 seconds ago. Now I've got to make up things to say for the next 10 seconds. So I'm going to sing to you. You guys hear that voice. One day I'm going to start my music career and you're all going to know my name as a music person as well. Didn't know about CD minus either. Yes, I knew about Get minus, but not CD minus. Well, peace out, everyone. Go say hello to Danny Stem. I'll see you all later.